1. Introduction to celestial navigation. 1.1 What is celestial navigation? Celestial navigation is a method of determining one's position on the Earth's surface using celestial bodies, such as the Sun, Moon, stars, and planets. It is a time-tested technique that has been used by sailors, explorers, and navigators for centuries to navigate the vast oceans and uncharted territories. By observing the positions of celestial bodies and comparing them to known reference points, navigators can accurately determine their latitude and longitude, allowing them to plot their course and reach their desired destination. At its core, celestial navigation relies on the principle that celestial bodies appear to move across the sky in predictable patterns due to the rotation and orbit of the Earth. By understanding these patterns and making precise observations, navigators can calculate their position relative to these celestial bodies and use that information to navigate. The primary celestial body used in celestial navigation is the Sun. During the day, the Sun's position in the sky can be used to determine the ship's latitude. By measuring the angle between the horizon and the Sun, known as the Sun's altitude, and comparing it to the Sun's declination, its position north or south of the celestial equator, navigators can calculate their latitude using mathematical formulas or specialized navigational tools. In addition to the Sun, navigators also rely on other celestial bodies for navigation. The most famous of these is the North Star, also known as Polaris. Located very close to the celestial North Pole, the North Star appears to remain stationary in the sky while all other stars appear to rotate around it. By measuring the angle between the horizon and the North Star, navigators can determine their latitude in the northern hemisphere. Stars other than the North Star can also be used for navigation. By identifying specific stars and measuring their angles above the horizon, navigators can calculate their latitude and, in some cases, their longitude. The positions of these stars are recorded in navigational almanacs and star charts, which provide the necessary data for celestial navigation calculations. In addition to the Sun and stars, the Moon and planets can also be used for celestial navigation. These celestial bodies have predictable orbits and positions in the sky, allowing navigators to use them as reference points for determining their position. However, their use requires more advanced calculations and specialized knowledge. Celestial navigation also relies on a set of navigational instruments to make accurate observations. The most important of these is the sextant, a precision instrument used to measure the angles between celestial bodies and the horizon. By aligning the sextant with the celestial body and the horizon, navigators can obtain precise measurements that are crucial for accurate calculations. Navigators also use navigational almanacs and star charts to determine the positions of celestial bodies at specific times and locations. These references provide the necessary data for celestial navigation calculations and are essential tools for any navigator. While modern technology has provided us with advanced navigation systems such as GPS, celestial navigation remains a valuable skill. It is not only a backup method in case of technological failure but also a way to connect with the ancient art of navigation and appreciate the wonders of the celestial sphere. Celestial navigation allows us to understand our place in the universe and navigate the world using the same techniques that guided explorers and sailors throughout history. 1.2 History of celestial navigation. Celestial navigation, the art of using celestial bodies to determine one's position and navigate across the vast oceans, has a rich and fascinating history that spans thousands of years. From ancient civilizations to modern explorers, humans have relied on the stars, Sun, Moon, and planets to guide their journeys. This section explores the historical development of celestial navigation and its significance in shaping the course of human exploration. Ancient origins. The origins of celestial navigation can be traced back to ancient civilizations such as the Egyptians, Greeks, and Phoenicians. These early seafaring cultures recognized the patterns of the stars and their relationship to the Earth's rotation. By observing the positions of celestial bodies at different times of the year, they were able to develop rudimentary methods of navigation. One of the earliest known examples of celestial navigation comes from the ancient Egyptians, who used the star Sirius to determine the annual flooding of the Nile River. They observed that when Sirius rose above the horizon just before sunrise, it signaled the imminent arrival of the floodwaters. This knowledge allowed them to plan their agricultural activities accordingly. Polynesian wayfinding. In the Pacific Islands, a remarkable system of celestial navigation known as wayfinding was developed by the Polynesians. Without the aid of modern instruments, these skilled navigators were able to traverse vast distances across the open ocean using only their knowledge of the stars, waves, and natural phenomena. Polynesian wayfinders memorized the positions of stars and their rising and setting points on the horizon. They also paid close attention to the movement of ocean swells, the flight patterns of birds, and the behavior of marine life. By combining these observations with their deep understanding of the celestial sphere, they could accurately determine their position and navigate between islands. Age of exploration. The Age of Exploration, spanning from the 15th to the 17th centuries, marked a significant turning point in the history of celestial navigation. As European explorers set sail to discover new trade routes and lands, they relied heavily on celestial navigation techniques to navigate the uncharted waters. One of the most famous navigators of this era was Christopher Columbus. In his voyages across the Atlantic, Columbus used celestial navigation to determine his latitude by measuring the angle between the horizon and the North Star. This allowed him to estimate his distance from the equator and navigate with greater accuracy. Development of navigational instruments. The development of navigational instruments greatly enhanced the accuracy and efficiency of celestial navigation. In the 18th century, the sextant was introduced, replacing the quadrant as the primary tool for measuring the angles between celestial bodies and the horizon. The sextant allowed navigators to make more precise observations and calculate their position with greater accuracy. Navigational almanacs and star charts also became essential tools for celestial navigation. These references provided information about the positions and movements of celestial bodies at specific times, enabling navigators to make accurate calculations and predictions. Modern applications. With the advent of satellite-based navigation systems like GPS, celestial navigation has become less prevalent in everyday navigation. However, it still holds great importance in certain fields such as aviation, space exploration, and maritime activities. In aviation, celestial navigation serves as a backup system in case of GPS failure or other technical issues. Pilots are trained to use celestial bodies as reference points to determine their position and maintain course accuracy. Similarly, in space exploration, celestial navigation plays a crucial role in determining the position and trajectory of spacecraft. By observing the positions of stars and planets, scientists can calculate the precise location of a spacecraft in the vastness of space. Conclusion. The history of celestial navigation is a testament to human ingenuity and our innate desire to explore the unknown. From ancient civilizations to modern-day adventurers, the stars have guided us on countless journeys across the seas and beyond. While technological advancements have made navigation easier, the art and science of celestial navigation continue to captivate us with its beauty and significance. By understanding its history, we can appreciate the legacy of celestial navigation and its enduring impact on human exploration. 1.3 Importance of celestial navigation. Celestial navigation, also known as astronavigation, is the art and science of using celestial bodies to determine one's position and navigate across vast expanses of land or sea. For centuries, before the advent of modern technology, celestial navigation was the primary method used by sailors, explorers, and travelers to navigate the world. While modern navigation systems such as GPS have largely replaced celestial navigation in everyday use, understanding the importance of celestial navigation can still be valuable in certain situations and for those who have a passion for the art of navigation. Historical significance. Celestial navigation has a rich history that dates back thousands of years. Ancient civilizations, such as the Greeks, Egyptians, and Polynesians, relied heavily on celestial navigation to explore and trade across vast distances. The ability to navigate by the stars allowed these civilizations to expand their knowledge, establish trade routes, and discover new lands. Without celestial navigation, many of the great explorations and discoveries throughout history would not have been possible. Self-reliance and independence. One of the key advantages of celestial navigation is its reliance on natural elements that are always present in the sky. Unlike modern navigation systems that can be affected by technical failures or signal disruptions, celestial navigation is based on the predictable movements of celestial bodies such as the sun, moon, stars, and planets. This self-reliance and independence from external systems make celestial navigation a valuable skill for those who venture into remote or challenging environments where modern technology may not be available or reliable. Backup navigation method. While GPS has revolutionized navigation and made it more accessible to the masses, it is not infallible. GPS signals can be blocked or disrupted by various factors such as tall buildings, dense forests, or adverse weather conditions. In such situations, having a backup navigation method like celestial navigation can be a lifesaver. By understanding the principles of celestial navigation, one can determine their position and navigate accurately even when other systems fail. Cultural and historical connection. Celestial navigation is deeply rooted in the history and culture of many civilizations. Learning and practicing celestial navigation can provide a unique connection to the past and the traditions of ancient seafarers and explorers. It allows us to appreciate the ingenuity and resourcefulness of those who navigated the world using only the stars. By studying celestial navigation, we can gain a deeper understanding of the historical significance of navigation and its impact on human civilization. Personal development and skill building. Mastering celestial navigation requires a combination of theoretical knowledge, practical skills, and experience. Learning celestial navigation can be a challenging but rewarding endeavor that fosters personal growth and skill building. It enhances critical thinking, problem-solving abilities, and spatial awareness. The process of observing and interpreting celestial bodies to determine one's position fosters a deeper connection with the natural world and develops a sense of awe and wonder for the universe. Nautical and aviation applications. While celestial navigation may not be the primary method of navigation in modern nautical and aviation industries, it still holds importance in certain situations. In the event of a catastrophic failure of electronic navigation systems, celestial navigation can serve as a reliable backup method for determining position and course. Additionally, celestial navigation is still taught and used in specialized fields such as offshore sailing, long-distance cruising, and transoceanic flights. Pilots and sailors who venture into remote areas or undertake long-duration journeys often rely on celestial navigation as a supplementary skill. Cultural preservation and revival. In recent years, there has been a resurgence of interest in celestial navigation as a means of preserving cultural heritage and reviving traditional navigation techniques. Indigenous communities, particularly in the Pacific Islands, have been actively working to pass down the knowledge of celestial navigation from one generation to the next. By embracing celestial navigation, these communities are not only preserving their cultural identity but also showcasing the importance of traditional knowledge and sustainable navigation practices. In conclusion, while celestial navigation may no longer be the primary method of navigation in our modern world, understanding its importance can still be valuable. Celestial navigation connects us to our historical roots, fosters self-reliance, and provides a backup method of navigation. It also offers personal development opportunities, holds relevance in specialized industries, and contributes to the preservation of cultural heritage. Whether for practical purposes or the sheer joy of navigating by the stars, celestial navigation continues to captivate and inspire those who seek to explore the world around them. 1.4 Basic Concepts of Celestial Navigation. Celestial navigation is a method of determining one's position on the Earth's surface using celestial bodies, such as the stars, sun, moon, and planets. It is a technique that has been used for centuries by sailors, explorers, and navigators to find their way across vast oceans and uncharted territories. In this section, we will explore the basic concepts of celestial navigation and how it works. The celestial sphere. To understand celestial navigation, it is essential to grasp the concept of the celestial sphere. The celestial sphere is an imaginary sphere that surrounds the Earth, with the observer at its center. It is a convenient way to visualize the positions of celestial bodies as they appear from Earth. Celestial coordinates. Just as we use latitude and longitude to locate points on the Earth's surface, celestial navigation uses celestial coordinates to pinpoint the position of celestial bodies on the celestial sphere. The two primary celestial coordinates used in celestial navigation are declination and right ascension. Declination is similar to latitude on Earth and measures the angular distance of a celestial body north or south of the celestial equator. It is expressed in degrees, minutes, and seconds. Right ascension, on the other hand, is similar to longitude on Earth and measures the angular distance of a celestial body eastward from a reference point called the vernal equinox. Right ascension is also expressed in degrees, minutes, and seconds. The celestial equator and the ecliptic. The celestial equator is an imaginary circle on the celestial sphere that is directly above the Earth's equator. It divides the celestial sphere into the northern and southern celestial hemispheres. The celestial equator is an essential reference point for celestial navigation. The ecliptic is another imaginary circle on the celestial sphere that represents the apparent path of the Sun throughout the year. It is inclined at an angle of approximately 23.5 degrees to the celestial equator. The ecliptic is significant because it is along this path that the Moon and planets can be found. The North Star and other celestial reference points. One of the most crucial celestial reference points in celestial navigation is the North Star, also known as Polaris. The North Star is located very close to the celestial North Pole, making it a reliable reference for determining the direction of true north. Other celestial bodies, such as specific stars or constellations, can also serve as reference points for navigation. For example, the Southern Cross is a well-known reference point in the southern hemisphere. Using celestial bodies for navigation. In celestial navigation, the position of celestial bodies is observed using a navigational instrument called a sextant. By measuring the angle between the horizon and a celestial body, such as the Sun or a star, the navigator can determine their position on the Earth's surface. By comparing the observed angle with the known position of the celestial body at a specific time, the navigator can calculate their latitude and longitude. This information is then used to plot a course and navigate accurately. Timekeeping in celestial navigation. Accurate timekeeping is crucial in celestial navigation. The position of celestial bodies changes with time, so it is essential to have precise time measurements when making observations. Historically, navigators used marine chronometers to keep accurate time at sea. Today, atomic clocks and GPS devices provide highly accurate time measurements. The importance of practice and skill. Celestial navigation is a skill that requires practice and experience to master. Navigators must be able to identify celestial bodies accurately, measure angles precisely, and perform complex calculations. It is a discipline that combines scientific knowledge, mathematical calculations, and practical observation. While modern technology has made navigation easier and more accessible, understanding the basic concepts of celestial navigation is still valuable. It allows navigators to have a deeper understanding of the principles behind modern navigation systems and provides a backup method in case of equipment failure or other unforeseen circumstances. In conclusion, celestial navigation is a fascinating and time-honored method of finding one's way using the stars and other celestial bodies. By understanding the basic concepts of celestial navigation, you can gain a deeper appreciation for the art and science of navigating by the stars. 2. Understanding the celestial sphere. 2.1 The celestial sphere and its components. Celestial navigation is a method of determining one's position on Earth by observing celestial bodies, such as stars, planets, and the Sun. At the heart of celestial navigation is the concept of the celestial sphere, an imaginary sphere surrounding the Earth, upon which the positions of celestial bodies are projected. Understanding the celestial sphere and its components is essential for successful navigation by the stars. The celestial sphere. The celestial sphere is a model used to represent the positions of celestial bodies as seen from Earth. It is an imaginary sphere with the Earth at its center. From any point on Earth, the celestial sphere appears as a dome overhead, with the stars seemingly fixed on its surface. This model simplifies the complex three-dimensional nature of space and allows navigators to visualize the positions of celestial bodies relative to their own location. Celestial coordinates. To navigate using the celestial sphere, astronomers and navigators use a system of celestial coordinates. These coordinates are similar to the latitude and longitude used on Earth's surface but are adapted for the celestial sphere. The two primary celestial coordinates are declination and right ascension. Declination is the celestial equivalent of latitude. It measures the angular distance of a celestial body north or south of the celestial equator. Declination is expressed in degrees, minutes, and seconds, with positive values for objects north of the celestial equator and negative values for objects south of it. Right ascension is the celestial equivalent of longitude. It measures the angular distance of a celestial body eastward along the celestial equator from a reference point called the vernal equinox. Right ascension is also expressed in degrees, minutes, and seconds, but it is measured in a clockwise direction from 0 to 360 degrees. The celestial equator and the ecliptic. The celestial equator is an imaginary circle on the celestial sphere that is directly above Earth's equator. It divides the celestial sphere into two equal halves, the northern celestial hemisphere and the southern celestial hemisphere. The celestial equator is an essential reference point for celestial navigation, as it helps determine the declination of celestial bodies. The ecliptic is another important circle on the celestial sphere. It represents the apparent path of the Sun throughout the year as seen from Earth. The ecliptic is inclined at an angle of approximately 23.5 degrees to the celestial equator. This inclination is due to Earth's axial tilt. The ecliptic intersects the celestial equator at 2 points called the vernal equinox and the autumnal equinox. These points mark the beginning of spring and autumn, respectively. The North Star and other celestial reference points. One of the most well-known celestial reference points is the North Star, also known as Polaris. The North Star is located very close to the celestial North Pole, making it a valuable navigational aid in the northern hemisphere. By aligning a navigational instrument, such as a sextant, with the North Star, navigators can determine their latitude. In addition to the North Star, there are other prominent stars and constellations that serve as reference points for celestial navigation. For example, the constellation Orion, with its distinctive belt of 3 stars, is often used to locate other celestial bodies. By identifying specific stars or constellations and their positions relative to the celestial equator, navigators can determine their direction and make accurate navigational calculations. Understanding the celestial sphere and its components is fundamental to mastering celestial navigation. By visualizing the celestial sphere, grasping celestial coordinates, and recognizing important reference points, navigators can confidently navigate by the stars. In the following sections, we will explore the navigational instruments and techniques used in conjunction with the celestial sphere to determine latitude and longitude accurately. 2.2 Celestial coordinates. Celestial navigation is a method of determining one's position on Earth by using celestial bodies, such as stars, planets, and the Sun. To effectively navigate using these celestial bodies, it is essential to understand celestial coordinates. Celestial coordinates provide a system for locating celestial objects in the sky and are analogous to latitude and longitude on Earth. Understanding celestial coordinates. Celestial coordinates are a set of coordinates used to locate celestial objects in the sky. They provide a reference system that allows navigators to pinpoint the position of stars, planets, and other celestial bodies. The two primary celestial coordinates used in celestial navigation are right ascension and declination. Right ascension. Right ascension, RA, is similar to longitude on Earth. It measures the angular distance of a celestial object eastward along the celestial equator from the vernal equinox. The vernal equinox is the point where the celestial equator intersects the ecliptic, and it serves as the reference point for measuring right ascension. Right ascension is measured in hours, minutes, and seconds, with 24 hours representing a full circle around the celestial sphere. To locate a celestial object using right ascension, one must know the current sidereal time, which is the time measured by the rotation of the Earth relative to the stars. By comparing the sidereal time with the right ascension of a celestial object, navigators can determine its position in the sky. Declination. Declination dec is similar to latitude on Earth. It measures the angular distance of a celestial object north or south of the celestial equator. Declination is measured in degrees, minutes, and seconds, with positive values indicating a position north of the celestial equator and negative values indicating a position south of the celestial equator. To locate a celestial object using declination, one must know its current declination value. This information can be obtained from navigational almanacs or star charts, which provide the declination values for various celestial objects at specific times. Using celestial coordinates for navigation. Celestial coordinates play a crucial role in celestial navigation. By knowing the right ascension and declination of a celestial object, navigators can determine its position in the sky and use it to calculate their own position on Earth. To navigate by the stars using celestial coordinates, the following steps can be followed. Determine the current sidereal time. The sidereal time can be obtained from navigational almanacs or calculated using specialized instruments or software. It represents the time measured by the rotation of the Earth relative to the stars. Identify the celestial object. Choose a celestial object, such as a star or planet, that is visible in the sky. Obtain its right ascension and declination values from navigational almanacs or star charts. Calculate the local hour angle. The local hour angle LHA is the angular distance between the observer's position and the celestial object, measured westward from the observer's meridian. It can be calculated by subtracting the observer's longitude from the right ascension of the celestial object. Determine the altitude and azimuth. Using the LHA and the observer's latitude, the altitude and azimuth of the celestial object can be calculated. The altitude is the angular distance above the horizon, while the azimuth is the angular distance measured clockwise from the observer's north. Take celestial observations. Use a sextant or other navigational instruments to measure the altitude and azimuth of the celestial object. These observations, along with the known values of the celestial object's right ascension and declination, can be used to calculate the observer's position on Earth. By repeating these steps with multiple celestial objects and comparing the calculated positions, navigators can obtain a more accurate fix on their location. Conclusion. Celestial coordinates provide a systematic way to locate celestial objects in the sky and are essential for celestial navigation. By understanding right ascension and declination, navigators can effectively use celestial bodies to determine their position on Earth. Celestial navigation not only offers a practical method of navigation but also connects us to the beauty and wonder of the night sky. 2.3 The celestial equator and the ecliptic. In celestial navigation, understanding the celestial sphere and its components is crucial. Two important components of the celestial sphere are the celestial equator and the ecliptic. These imaginary lines play a significant role in determining the positions of celestial bodies and aiding in navigation. The celestial equator. The celestial equator is an imaginary line that divides the celestial sphere into two equal halves, just like the Earth's equator divides the Earth into the northern and southern hemispheres. It is a projection of the Earth's equator onto the celestial sphere. The celestial equator is always directly above the Earth's equator and runs east to west. One of the primary uses of the celestial equator in celestial navigation is to determine the declination of celestial bodies. Declination is similar to latitude on Earth and measures how far north or south a celestial body is from the celestial equator. By knowing the declination of a celestial body, navigators can determine their position relative to the celestial equator. To find the celestial equator, one can imagine extending the Earth's equator into the sky. The celestial equator intersects with the horizon at the east and west points, known as the celestial east and celestial west. These points are essential for celestial navigation, as they help determine the azimuth or bearing of celestial bodies. The ecliptic. The ecliptic is another imaginary line on the celestial sphere that plays a crucial role in celestial navigation. It represents the apparent path of the Sun throughout the year as observed from Earth. The ecliptic is inclined at an angle of approximately 23.5 degrees to the celestial equator. The tilt of the Earth's axis causes the Sun's apparent path to vary throughout the year, creating the changing seasons. The ecliptic intersects the celestial equator at 2 points known as the vernal equinox and the autumnal equinox. The vernal equinox marks the beginning of spring in the northern hemisphere, while the autumnal equinox marks the beginning of fall. The ecliptic is significant in celestial navigation because it is the path followed by the Sun, Moon, and planets. By observing the positions of these celestial bodies along the ecliptic, navigators can determine their own position and make accurate calculations for celestial navigation. Relationship between the celestial equator and the ecliptic. The celestial equator and the ecliptic are not parallel but intersect at 2 points, the vernal and autumnal equinoxes. These points are essential reference points for celestial navigation. The vernal equinox, also known as the first point of Aries, is the point where the Sun crosses the celestial equator from south to north during the spring equinox. It marks the beginning of the celestial coordinate system and is used as a reference point for measuring celestial longitudes. The autumnal equinox, also known as the first point of Libra, is the point where the Sun crosses the celestial equator from north to south during the fall equinox. It is another reference point for measuring celestial longitudes. The relationship between the celestial equator and the ecliptic is crucial for determining the positions of celestial bodies. By measuring the angular distance of a celestial body from the celestial equator and the ecliptic, navigators can calculate the body's declination and its position relative to the vernal equinox. Understanding the celestial equator and the ecliptic is fundamental to celestial navigation. These imaginary lines provide navigators with reference points and help them determine the positions of celestial bodies accurately. By utilizing the celestial equator and the ecliptic, navigators can navigate by the stars and find their way across the vast oceans or even through space. 2.4 The North Star and other celestial reference points. In celestial navigation, the North Star, also known as Polaris, plays a crucial role as a reference point for determining direction and latitude. Located almost directly above the Earth's North Pole, the North Star appears stationary in the night sky while all other stars appear to rotate around it. This makes it an excellent celestial reference point for navigators in the Northern Hemisphere. The North Star as a guide. One of the primary uses of the North Star in celestial navigation is to determine true north. By aligning a navigational instrument, such as a sextant, with the North Star, mariners can establish a reference point for their course. The angle between the North Star and the horizon, known as the star's altitude, can be measured using the sextant. This measurement, along with the observer's known latitude, can then be used to calculate the ship's position. To find the North Star, one can use the Big Dipper, which is part of the Ursa Major constellation. The two outermost stars in the Big Dipper's bowl, known as the pointer stars, can be used to locate Polaris. By drawing an imaginary line through these two stars and extending it beyond the bowl, one will eventually reach the North Star. Other celestial reference points. While the North Star is a reliable reference point in the Northern Hemisphere, navigators in other parts of the world must rely on different celestial bodies. Here are some other important celestial reference points used in celestial navigation. Southern Cross. In the Southern Hemisphere, the Southern Cross, or crux, serves as a prominent celestial reference point. This constellation consists of 4 bright stars that form a cross shape. By locating the Southern Cross and measuring its altitude, navigators can determine their latitude in the Southern Hemisphere. Sun. During the day, the Sun becomes the primary celestial reference point. By measuring the Sun's altitude at local noon, when it reaches its highest point in the sky, navigators can determine their latitude. Additionally, by measuring the angle between the Sun and a known reference point, such as the North Star, navigators can determine their longitude. Moon. The Moon can also be used as a celestial reference point, particularly during the night. By measuring the Moon's altitude and knowing its position in the sky at a specific time, navigators can determine their latitude and longitude. The Moon's position can be determined using navigational almanacs or software that provides accurate celestial data. Planets and bright stars. Certain planets, such as Venus, Mars, Jupiter, and Saturn, as well as bright stars like Sirius and Betelgeuse, can also serve as celestial reference points. These celestial bodies are easily identifiable and can be used to determine direction and approximate latitude. Using multiple celestial reference points. In celestial navigation, it is common to use multiple celestial reference points to increase accuracy and confirm position. By taking measurements of different celestial bodies at the same time, navigators can cross-reference their observations and reduce the margin of error. This technique, known as celestial triangulation, involves measuring the altitude of 2 or more celestial bodies and using their intersecting lines to determine the observer's position. By combining the use of the North Star, other celestial reference points, and the principles of celestial navigation, mariners can confidently navigate the open seas. While modern technology has provided alternative methods of navigation, understanding celestial reference points and their significance is still valuable for both practical and historical reasons. Celestial navigation allows mariners to connect with the ancient art of navigating by the stars and appreciate the legacy of those who came before them. 3. Navigational instruments for celestial navigation. 3.1 Sextants and octants. Sextants and octants are essential navigational instruments used in celestial navigation. These instruments allow sailors and navigators to measure the angles between celestial bodies and the horizon, enabling them to determine their position on the Earth's surface. In this section, we will explore the history, components, and usage of sextants and octants in celestial navigation. History of sextants and octants. The development of sextants and octants can be traced back to the 18th century when mariners sought more accurate methods of determining their position at sea. Before the invention of these instruments, navigators relied on cross staffs and astrolabes, which had limitations in terms of accuracy and ease of use. The octant, invented by Thomas Godfrey in 1730, was the precursor to the sextant. It was named after the fact that it could measure angles up to 90 degrees, or 1/8 of a circle. The octant had a reflecting mirror that allowed the observer to align the image of a celestial body with the horizon. However, the octant had a limited field of view and was not as accurate as the later sextant. The sextant, developed independently by John Hadley and Thomas Godfrey in the mid-18th century, improved upon the design of the octant. It featured a larger arc, allowing for more precise measurements. The sextant also incorporated a double reflecting system using 2 mirrors, which eliminated the need for a horizon mirror. This innovation greatly improved accuracy and made the instrument easier to use. Components of sextants and octants. Sextants and octants consist of several key components that enable navigators to measure angles accurately. These components include frame. The frame of a sextant or octant is typically made of brass or another durable material. It provides the structure and stability for the instrument. Arc. The arc is a curved scale attached to the frame, usually graduated in degrees. It allows the navigator to measure the angle between 2 objects, such as a celestial body and the horizon. Index mirror. The index mirror is a small, flat mirror mounted at a 45-degree angle to the frame. It reflects the image of the celestial body being observed. Horizon mirror. The horizon mirror is a larger mirror mounted parallel to the index mirror. It reflects the image of the horizon, allowing the navigator to align it with the celestial body's image. Telescope. The telescope is mounted on the frame and is used to observe the celestial bodies in the horizon. It is equipped with a crosshair or reticle to aid in precise measurements. Micrometer drum. The micrometer drum is a fine adjustment mechanism that allows the navigator to make small adjustments to the position of the index mirror. Using sextants and octants. To use a sextant or octant for celestial navigation, the navigator follows a series of steps. Calibration. Before taking measurements, the navigator must calibrate the instrument by aligning the index mirror with the horizon mirror. This ensures accurate readings. Observing celestial bodies. The navigator uses the telescope to observe a celestial body, such as the sun, moon, or a star. By aligning the image of the celestial body with the horizon, the navigator can measure the angle between them using the arc. Recording measurements. The navigator records the measured angle, along with the time of the observation. This information is crucial for calculating the position. Correcting for instrument errors. Sextants and octants can have inherent errors due to imperfections in their construction. Navigators must apply corrections to account for these errors to obtain accurate results. Calculating position. Using the measured angles, along with other navigational data such as the time and the known position of the celestial body, the navigator can calculate their position using mathematical formulas or specialized navigational tables. Sextants and octants have been instrumental in maritime navigation for centuries. Despite advancements in technology, these instruments continue to be used by sailors, navigators, and enthusiasts who appreciate the art and science of celestial navigation. They serve as a reminder of the rich history and tradition of navigating by the stars. 3.2 Navigational Almanacs and Star Charts. Navigating by the stars requires accurate and up-to-date information about the positions of celestial bodies. This information is typically found in navigational almanacs and star charts. Navigational almanacs provide data on the positions of stars, planets, and other celestial objects at specific times, while star charts are graphical representations of the night sky that help mariners identify and locate these celestial bodies. Navigational almanacs. Navigational almanacs are essential tools for celestial navigation. They contain detailed tables and diagrams that provide information about the positions of celestial bodies at specific times. These almanacs are typically published annually and are based on astronomical calculations and observations. One of the most widely used navigational almanacs is the Nautical Almanac, which provides data on the positions of the sun, moon, planets, and selected stars. It also includes information on the times of sunrise, sunset, moonrise, and moonset, as well as data for calculating the altitude and azimuth of celestial bodies. Navigational almanacs are organized by date and time, allowing navigators to determine the positions of celestial bodies at any given moment. By comparing the observed altitude and azimuth of a celestial body with the corresponding values in the almanac, mariners can calculate their latitude and longitude. In addition to the Nautical Almanac, there are other specialized almanacs available for specific regions or purposes. For example, the Air Almanac provides data specifically for aviation purposes, while the Astronomical Almanac offers comprehensive astronomical information for both professional and amateur astronomers. Star charts. Star charts, also known as celestial charts or sky maps, are graphical representations of the night sky. They depict the positions and relative brightness of stars, constellations, and other celestial objects visible from a specific location and at a specific time. Star charts are invaluable tools for identifying and locating celestial bodies during celestial navigation. They help mariners recognize patterns of stars, known as constellations, and locate specific stars or groups of stars that can be used as reference points. Star charts are typically designed for specific latitudes and are organized by the time of year. They show the positions of stars and constellations at different times throughout the night, allowing navigators to determine their position based on the observed celestial bodies. In addition to printed star charts, there are also digital versions available that can be used on electronic devices such as smartphones or tablets. These digital star charts often have additional features such as the ability to overlay the chart on a live view of the night sky using the device's camera. When using star charts for celestial navigation, it is important to consider factors such as light pollution and atmospheric conditions that may affect visibility. It is also crucial to have a basic understanding of celestial coordinates and how to read the charts accurately. Using navigational almanacs and star charts. To navigate by the stars using navigational almanacs and star charts, mariners follow a series of steps. Determine the time and date of observation. Consult the navigational almanac to obtain the positions of celestial bodies at that specific time. Identify the celestial bodies visible from the observer's location using the star chart. Measure the altitude and azimuth of the selected celestial body using a sextant or other navigational instrument. Compare the observed values with the corresponding values in the navigational almanac to calculate latitude and longitude. Repeat the process for multiple celestial bodies to obtain more accurate results and cross-check the calculations. Navigational almanacs and star charts are indispensable tools for celestial navigation. They provide mariners with the necessary information to determine their position accurately using the stars. By mastering the use of these tools, navigators can confidently navigate the open seas and explore the wonders of the night sky. 3.3 Timekeeping devices. Timekeeping devices play a crucial role in celestial navigation. Accurate time measurement is essential for determining celestial positions and calculating navigational data. In this section, we will explore the various timekeeping devices used in celestial navigation and their significance in the process. Chronometers. One of the most important timekeeping devices in celestial navigation is the chronometer. A chronometer is a highly accurate and precise mechanical clock that is designed to keep time consistently, even in challenging conditions such as onboard a ship or aircraft. These timepieces are built to withstand the motion, temperature changes, and vibrations that can affect regular clocks. Chronometers are typically set to Greenwich Mean Time (GMT) or Coordinated Universal Time (UTC), which serves as the reference time for celestial navigation calculations. By comparing the chronometer's time with the observed celestial events, navigators can determine their position accurately. Nautical almanacs. Nautical almanacs are comprehensive publications that provide essential astronomical data for celestial navigation. These almanacs contain tables and charts that list the positions of celestial bodies at specific times, allowing navigators to calculate their own position based on these observations. The almanacs provide information on the positions of the sun, moon, planets, and stars, as well as data on sunrise, sunset, moonrise, and moonset times. They also include tables for calculating the altitude and azimuth of celestial bodies at specific times and locations. Navigators use the nautical almanac in conjunction with their timekeeping devices to determine the precise moment of observation and the corresponding celestial body's position. This information is then used to calculate the observer's latitude and longitude. Marine chronometers. Marine chronometers are specialized chronometers designed specifically for use at sea. These timekeeping devices are highly accurate and reliable, even in the harsh marine environment. Marine chronometers are typically housed in a gimbal mount, which allows them to remain level and stable despite the motion of the ship. Marine chronometers are set to GMT or UTC and are used to determine the ship's longitude by comparing the local time with the GMT or UTC time. By knowing the time difference between the ship's location and the reference time, navigators can calculate their longitude accurately. Radio time signals. In addition to mechanical timekeeping devices, radio time signals are also used in celestial navigation. These signals are transmitted by radio stations and provide accurate time information that can be used to synchronize onboard clocks and chronometers. Radio time signals are broadcasted by various national timekeeping organizations, such as the National Institute of Standards and Technology (NIST) in the United States or the National Physical Laboratory (NPL) in the United Kingdom. These signals are typically transmitted on specific frequencies and can be received by specialized radio receivers onboard ships or aircraft. By synchronizing their timekeeping devices with the radio time signals, navigators can ensure that their clocks and chronometers are accurate and consistent with the reference time used in celestial navigation calculations. GPS time. With the advent of Global Positioning System (GPS) technology, GPS time has become another important reference for celestial navigation. GPS satellites have highly accurate atomic clocks onboard, and the GPS system provides precise time information to GPS receivers. GPS time is based on the Coordinated Universal Time (UTC) standard but is not subject to leap seconds adjustments. This makes GPS time a reliable and consistent reference for celestial navigation calculations. Navigators can use GPS receivers to obtain accurate time information, which can be used in conjunction with celestial observations to determine their position accurately. In conclusion, timekeeping devices are essential tools in celestial navigation. Chronometers, nautical almanacs, marine chronometers, radio time signals, and GPS time all play a crucial role in ensuring accurate time measurement for celestial navigation calculations. By utilizing these devices effectively, navigators can confidently navigate by the stars and determine their position accurately on the Earth's surface. 3.4 Calculators and computers for celestial navigation. In the modern era, celestial navigation has been greatly aided by the development of calculators and computers. These technological advancements have revolutionized the way navigators can determine their position using celestial bodies. By automating complex calculations and providing accurate data, calculators and computers have made celestial navigation more accessible and efficient. The role of calculators. Calculators play a crucial role in celestial navigation by simplifying and speeding up the calculations involved in determining a position. They are particularly useful for solving trigonometric equations and performing complex mathematical operations. With the help of calculators, navigators can quickly and accurately calculate the altitude and azimuth of celestial bodies, as well as their position on the celestial sphere. One of the most common uses of calculators in celestial navigation is for determining the time of celestial events, such as sunrise, sunset, and meridian passage. By inputting the necessary data, including the observer's location and the date, calculators can provide precise times for these events. This information is essential for accurately determining the observer's longitude. The advantages of computers. Computers have taken celestial navigation to a whole new level by providing advanced software programs specifically designed for this purpose. These programs can perform complex calculations, generate star charts, and even simulate celestial events. They offer a wide range of features and functionalities that greatly enhance the accuracy and efficiency of celestial navigation. One of the key advantages of using computers for celestial navigation is the ability to access vast databases of celestial information. These databases contain detailed information about celestial bodies, including their positions, magnitudes, and other relevant data. By accessing this information, navigators can accurately determine the position of celestial bodies at any given time, making it easier to establish their own position. Computers also allow for real-time calculations and updates. By connecting to GPS systems or other navigational devices, computers can continuously update the observer's position based on celestial observations. This real-time feedback enables navigators to make immediate adjustments to their course and stay on track. Celestial navigation software. There are several software programs available that cater specifically to celestial navigation. These programs offer a range of features, including celestial body databases, star charts, and calculation tools. Some software even includes augmented reality capabilities, allowing navigators to overlay celestial bodies onto a live view of the sky. One popular software program is Stellarium, which provides a realistic and interactive 3D simulation of the night sky. It allows users to navigate through time and space, observing the positions of celestial bodies at any given moment. Stellarium also includes a powerful search function, enabling users to locate specific celestial bodies and obtain detailed information about them. Another widely used software program is CelesteNav, which offers a comprehensive suite of tools for celestial navigation. It includes features such as celestial body databases, calculation tools, and star charts. CelesteNav also allows users to input their own observations and calculate their position based on these observations. Limitations and considerations. While calculators and computers have greatly enhanced celestial navigation, it is important to recognize their limitations and consider certain factors when relying on them. Firstly, navigators should always have a backup plan in case of technical failures or power outages. It is essential to carry traditional navigational tools, such as a sextant and nautical almanac, as a backup in case electronic devices fail. Additionally, navigators should be aware of the potential for errors in calculations and data input. Even with advanced software programs, human error can still occur. It is crucial to double-check calculations and verify data to ensure accuracy. Furthermore, navigators should be mindful of the reliance on technology and the potential for over-reliance. While calculators and computers can simplify the process of celestial navigation, it is important to maintain a solid understanding of the underlying principles and concepts. Navigators should continue to develop their skills in manual celestial navigation to ensure they can navigate effectively in any situation. In conclusion, calculators and computers have revolutionized celestial navigation by automating complex calculations and providing accurate data. They have made celestial navigation more accessible and efficient, allowing navigators to determine their position with greater ease and accuracy. However, it is important to recognize the limitations of technology and maintain a solid understanding of manual celestial navigation techniques. By combining the benefits of technology with traditional navigational skills, navigators can confidently navigate by the stars in the modern world. 4. Determining latitude by celestial navigation. 4.1 Using the sun to determine latitude. One of the fundamental principles of celestial navigation is using celestial bodies, such as the sun, to determine latitude. Latitude is the angular distance north or south of the equator and is crucial for determining a ship or aircraft's position on the Earth's surface. By observing the sun's position in the sky at a specific time, navigators can calculate their latitude accurately. In this section, we will explore the process of using the sun to determine latitude and the necessary calculations involved. To determine latitude using the sun, navigators rely on the concept of the sun's declination. The declination is the angular distance of the sun north or south of the celestial equator. It varies throughout the year due to the tilt of the Earth's axis and the elliptical shape of its orbit around the sun. Navigators consult nautical almanacs or other reliable sources to obtain the sun's declination for a given date. The first step in using the sun to determine latitude is to measure the sun's altitude, which is the angle between the horizon and the center of the sun. This measurement can be taken using a sextant, a navigational instrument specifically designed for celestial observations. The sextant allows navigators to measure angles accurately by aligning the horizon with the celestial body being observed. To measure the sun's altitude, the navigator selects a suitable time when the sun is at its highest point in the sky, known as local apparent noon. At this moment, the sun's altitude is equal to the observer's latitude. However, due to various factors such as the Earth's axial tilt and the observer's position, the sun may not be directly overhead at local apparent noon. Therefore, the navigator must make corrections to the measured altitude to obtain an accurate latitude. To correct the measured altitude, navigators use a process called reduction. Reduction involves applying corrections for various factors that affect the sun's position in the sky. These factors include the observer's height above sea level, the dip of the horizon, and the refraction of light as it passes through the Earth's atmosphere. By applying these corrections, navigators can obtain the true altitude of the sun. Once the true altitude is determined, the navigator can compare it to the sun's declination for that date. The difference between the true altitude and the declination is known as the co-latitude. The co-latitude is equal to 90 degrees minus the observer's latitude. By subtracting the co-latitude from 90 degrees, the navigator can calculate their latitude accurately. It is important to note that the process of determining latitude using the sun requires precise timekeeping. Navigators must have access to accurate timekeeping devices, such as chronometers or atomic clocks, to ensure the measurements are taken at the correct moment. Any errors in timekeeping can lead to significant inaccuracies in the latitude calculation. In addition to using the sun's altitude, navigators can also determine latitude by observing the sun's azimuth. The azimuth is the angular distance of the sun measured clockwise from true north. By measuring the sun's azimuth at a specific time, navigators can calculate their latitude using trigonometric formulas. However, this method requires more complex calculations and is less commonly used than the altitude method. In conclusion, using the sun to determine latitude is a fundamental technique in celestial navigation. By measuring the sun's altitude and applying necessary corrections, navigators can accurately calculate their latitude. This process relies on precise timekeeping and access to reliable sources of celestial data. While the altitude method is more straightforward, the azimuth method provides an alternative approach for determining latitude. By mastering these techniques, navigators can confidently navigate the open seas or the vast skies using the celestial bodies as their guide. 4.2 Using the North Star to determine latitude. One of the most reliable and widely used celestial reference points for determining latitude is the North Star, also known as Polaris. The North Star is a bright star located very close to the celestial North Pole, making it an excellent navigational tool for determining latitude in the Northern Hemisphere. To use the North Star for celestial navigation, you need to understand its position in the night sky and how it relates to your latitude. Here are the steps to determine latitude using the North Star. Locate the North Star. The North Star can be found by locating the Big Dipper, which is part of the Ursa Major constellation. The two outer stars of the Big Dipper's bowl point directly to the North Star. Follow an imaginary line from these two stars, and you will find Polaris, the North Star. Determine the altitude of the North Star. Using a sextant or other navigational instrument, measure the angle between the horizon and the North Star. This angle is known as the altitude. The altitude of the North Star is equal to your latitude. Correct for observer's height. If you are on a ship or any elevated platform, you need to correct the altitude reading for your observer's height. Subtract the height of your eye level above sea level from the measured altitude to obtain the corrected altitude. Account for refraction. Refraction is the bending of light as it passes through the Earth's atmosphere. It causes celestial bodies to appear slightly higher in the sky than they actually are. To account for refraction, apply a correction factor to the corrected altitude. The amount of correction depends on atmospheric conditions and can be obtained from navigational tables or formulas. Calculate latitude. Once you have the corrected altitude, you can determine your latitude by subtracting it from 90 degrees. For example, if the corrected altitude is 40 degrees, your latitude would be 90 to 40 equals 50 degrees. It is important to note that the North Star method is most accurate near the celestial North Pole. As you move away from the pole, the altitude of the North Star decreases, making it less precise for determining latitude. In addition, the North Star method is only applicable in the Northern Hemisphere. In the Southern Hemisphere, there is no star equivalent to the North Star. Using the North Star to determine latitude has been a reliable method for centuries, especially for sailors navigating the open seas. It provides a fixed reference point in the night sky that remains relatively constant throughout the year. However, there are a few considerations and limitations to keep in mind when using this method. Atmospheric conditions. The accuracy of celestial navigation, including using the North Star, can be affected by atmospheric conditions such as haze, fog, or clouds. These conditions can obscure the visibility of stars and make it challenging to obtain accurate altitude measurements. Instrument accuracy. The accuracy of your navigational instrument, such as a sextant, is crucial for obtaining precise altitude measurements. Regular calibration and maintenance of your instrument are necessary to ensure accurate readings. Observer's skill. Celestial navigation requires practice and skill in using navigational instruments and interpreting the measurements. It is essential to understand the principles and techniques involved in order to obtain accurate results. Time of observation. The accuracy of latitude determination using the North Star can vary depending on the time of observation. The North Star's position changes slightly throughout the night due to the Earth's rotation. Therefore, it is recommended to take multiple observations over a period of time and average the results for increased accuracy. Despite these considerations, the North Star remains a valuable tool for celestial navigation, particularly for determining latitude in the Northern Hemisphere. Its reliability and ease of use have made it a staple in the field of navigation for centuries. By understanding the principles and techniques involved in using the North Star, navigators can confidently navigate the seas and explore the world using the stars as their guide. 4.3 Using other celestial bodies to determine latitude. While the North Star is a reliable and commonly used celestial reference point for determining latitude, there are other celestial bodies that can also be used for this purpose. In celestial navigation, the position of these bodies in the sky can provide valuable information about the observer's latitude. Let's explore some of these celestial bodies and how they can be used in the navigation process. The Sun. The Sun, being the most prominent celestial body, can also be used to determine latitude. By measuring the angle between the horizon and the highest point the Sun reaches in the sky at noon, known as the Sun's maximum altitude, navigators can calculate their latitude. This method is similar to using the North Star, but instead of measuring the angle to the celestial pole, the angle is measured to the Sun. To determine latitude using the Sun, navigators need to know the exact time of local noon, which can be obtained from a reliable timekeeping device. At local noon, when the Sun is at its highest point in the sky, the navigator measures the angle between the horizon and the Sun using a sextant or similar instrument. By referring to tables or mathematical formulas, the navigator can then calculate their latitude based on this angle. The Moon. The Moon, with its distinct phases and predictable movements, can also be used as a celestial reference point for determining latitude. Similar to the Sun, the Moon's maximum altitude can be measured to calculate latitude. However, due to the Moon's orbital motion, this method requires more precise calculations. To determine latitude using the moon, navigators need to measure the angle between the horizon and the moon's highest point in the sky, just like with the sun. However, since the moon's position changes significantly over a short period, navigators must take into account the moon's altitude and azimuth at a specific time. This information can be obtained from navigational almanacs or specialized software. Planets. In addition to the sun and the moon, certain planets can also be used to determine latitude. Planets such as Venus, Mars, Jupiter, and Saturn are bright enough to be observed with the naked eye and can serve as reliable celestial reference points. By measuring their maximum altitudes and applying the necessary calculations, navigators can determine their latitude. Similar to using the sun and the moon, navigators need to measure the angle between the horizon and the planet's highest point in the sky. This angle, along with the time of observation, is used to calculate latitude using tables or mathematical formulas specific to each planet. Other celestial bodies. Apart from the sun, the moon, and the planets, there are other celestial bodies that can be used to determine latitude, although they may require more advanced techniques and equipment. These include stars, asteroids, and even comets. However, due to their relatively small size and distant nature, precise measurements and calculations are necessary to obtain accurate latitude readings. Navigators can use star charts and navigational almanacs to identify specific stars and their positions in the sky. By measuring the angle between the horizon and a chosen star's highest point, navigators can calculate their latitude. This method requires a clear view of the night sky and a good understanding of celestial coordinates. Asteroids and comets, although less commonly used, can also provide valuable information for determining latitude. However, due to their unpredictable movements and changing positions, accurate observations and calculations are more challenging. In conclusion, while the North Star is a reliable celestial reference point for determining latitude, there are other celestial bodies that can be used in celestial navigation. The sun, the moon, planets, stars, asteroids, and comets all have their unique characteristics and can provide valuable information about an observer's latitude. By understanding their movements, measuring their altitudes, and applying the necessary calculations, navigators can confidently navigate by the stars and explore the vastness of the celestial sphere. 4.4 Calculating latitude with navigational instruments. In celestial navigation, determining latitude is a crucial step in finding your position on the Earth's surface. While there are various methods to calculate latitude using celestial bodies, navigational instruments play a significant role in accurately measuring celestial angles and making precise calculations. These instruments provide the necessary tools to determine your latitude with greater accuracy and efficiency. In this section, we will explore the different navigational instruments used in celestial navigation and how they aid in calculating latitude. Navigational instruments for celestial navigation. Before delving into the specific instruments used for calculating latitude, let's briefly review the navigational instruments commonly employed in celestial navigation. Sextants and octants. Sextants and octants are essential tools in celestial navigation. These instruments allow navigators to measure the angle between a celestial body, such as the sun or a star, and the horizon. By measuring this angle, known as the altitude, and combining it with the time of the observation, navigators can determine their latitude. Navigational almanacs and star charts. Navigational almanacs and star charts provide valuable information about the positions of celestial bodies at specific times. These references contain tables and diagrams that enable navigators to identify celestial bodies and their respective positions accurately. By consulting these references, navigators can determine which celestial bodies are suitable for latitude calculations at a given time. Timekeeping devices. Accurate timekeeping is crucial in celestial navigation. Timekeeping devices, such as marine chronometers or accurate wristwatches, are used to record the time of celestial observations. Precise time measurements are necessary for calculating the Greenwich hour angle, GHA, of celestial bodies, which is essential for determining latitude. Calculators and computers for celestial navigation. In modern celestial navigation, calculators and computers have become valuable tools for performing complex calculations quickly and accurately. These devices can handle the intricate mathematical calculations involved in celestial navigation, making the process more efficient and reducing the chances of errors. Calculating latitude with navigational instruments. Now that we have reviewed the navigational instruments used in celestial navigation, let's explore how these instruments aid in calculating latitude. Sextants and octants. Sextants and octants are the primary instruments used to measure the altitude of celestial bodies. To calculate latitude using these instruments, navigators measure the angle between the celestial body and the horizon. This angle, known as the observed altitude, is then corrected for various factors such as instrument errors, atmospheric refraction, and index error. Once the corrections are applied, the resulting value represents the true altitude of the celestial body. By comparing this true altitude with the known declination of the celestial body, navigators can determine their latitude. Navigational almanacs and star charts. Navigational almanacs and star charts provide navigators with the necessary information to identify celestial bodies accurately. These references contain tables that list the declinations of celestial bodies at specific times. By consulting the almanac or star chart, navigators can determine which celestial bodies are suitable for latitude calculations at a given time. Once the celestial body is identified, the navigator can measure its altitude using a sextant or octant and compare it with the known declination to calculate latitude. Timekeeping devices. Accurate timekeeping is crucial for celestial navigation. Timekeeping devices, such as marine chronometers or accurate wristwatches, are used to record the time of celestial observations. The time of the observation is then used to calculate the Greenwich hour angle, GHA, of the celestial body. The GHA, combined with the observed altitude, allows navigators to determine their latitude using mathematical formulas or specialized tables. Calculators and computers for celestial navigation. Calculators and computers have revolutionized celestial navigation by simplifying complex calculations. These devices can handle the intricate mathematical formulas involved in celestial navigation, making the process more efficient and accurate. By inputting the observed altitude, time of observation, and other relevant data, calculators and computers can quickly calculate latitude using specialized software or algorithms. In conclusion, navigational instruments play a vital role in calculating latitude in celestial navigation. Sextants and octants allow navigators to measure the altitude of celestial bodies accurately, while navigational almanacs and star charts provide the necessary information to identify celestial bodies and their declinations. Timekeeping devices ensure accurate time measurements, which are crucial for calculating the Greenwich hour angle. Finally, calculators and computers simplify complex calculations, making the process more efficient and reducing the chances of errors. By utilizing these navigational instruments, celestial navigators can determine their latitude with greater accuracy and confidence, enabling them to navigate the vast oceans and skies with precision. 5. Determining longitude by celestial navigation. 5.1 Understanding the concept of longitude. Longitude is a fundamental concept in celestial navigation. It is the measurement of how far east or west a point on the Earth is from the prime meridian, which is the reference line for longitude. While latitude measures the distance north or south of the equator, longitude determines the position in the east-west direction. The need for longitude. Navigating by the stars requires an understanding of longitude because it allows sailors and explorers to determine their exact position on the Earth's surface. In the past, accurately determining longitude was a significant challenge and often led to navigational errors and shipwrecks. The ability to accurately measure longitude was crucial for safe and successful voyages. Historical development. The concept of longitude has a fascinating history. In the early days of navigation, sailors relied on dead reckoning, which involved estimating their position based on their previous course and speed. However, this method was prone to errors and did not provide accurate results. In the 18th century, the British government offered a substantial reward for anyone who could develop a reliable method for determining longitude at sea. This led to the invention of the marine chronometer by John Harrison. The marine chronometer was a highly accurate timekeeping device that allowed sailors to compare the local time with the time at a known reference point, such as Greenwich, England. The time difference between the two locations provided the longitude. Measuring longitude. There are several methods for determining longitude using celestial navigation. One of the most common methods is using the sun's position. By measuring the angle between the sun and the observer's local meridian at a specific time, sailors can calculate their longitude. This method requires accurate timekeeping and a sextant or other navigational instrument to measure the angle. Another method involves using the moon's position. By observing the moon and comparing its position with a known reference point, such as a star or planet, sailors can calculate their longitude. This method is particularly useful when the moon is visible during the day or when other celestial bodies are not visible. Additionally, sailors can determine longitude by observing other celestial bodies, such as planets or stars. By measuring the angle between the celestial body and the observer's local meridian, sailors can calculate their longitude. This method requires knowledge of the celestial body's position and accurate timekeeping. Challenges and limitations. Determining longitude accurately can be challenging due to various factors. One of the main challenges is the need for precise timekeeping. Any errors in time measurement can lead to significant inaccuracies in longitude calculations. Therefore, navigators must have reliable timekeeping devices, such as chronometers or accurate atomic clocks. Another challenge is the reliance on clear visibility of celestial bodies. Cloudy or foggy weather can obstruct the view of the stars, making it difficult to measure their positions accurately. Similarly, during the day, the brightness of the sun can make it challenging to measure its angle accurately. Furthermore, the accuracy of longitude calculations can be affected by instrumental errors. Navigational instruments, such as sextants, may have slight inaccuracies that can impact the final longitude calculation. Therefore, regular calibration and maintenance of these instruments are essential. Modern techniques. In modern times, advancements in technology have made determining longitude more accessible and accurate. Global navigation satellite systems (GNSS), such as the Global Positioning System (GPS), have revolutionized navigation by providing precise positioning information anywhere on Earth. GPS receivers use signals from multiple satellites to calculate latitude, longitude, and altitude accurately. While GPS has become the primary method for determining longitude, celestial navigation still holds value. It serves as a backup method in case of GPS failure or as a means of cross-checking GPS readings. Additionally, celestial navigation techniques are still taught and used in certain fields, such as aviation and marine navigation, to ensure navigators have a comprehensive understanding of their position. Conclusion. Understanding the concept of longitude is crucial for celestial navigation. It allows sailors and explorers to determine their exact position on the Earth's surface by measuring their distance east or west from the prime meridian. While historical methods relied on celestial observations and accurate timekeeping, modern technology, such as GPS, has made determining longitude more accessible and accurate. However, celestial navigation techniques continue to hold value as backup methods and for their educational and historical significance. 5.2 Using the Sun to determine longitude. One of the most important aspects of celestial navigation is determining longitude, which refers to the east-west position of a vessel or observer on the Earth's surface. While determining latitude can be relatively straightforward using celestial bodies such as the North Star, determining longitude presents a greater challenge. However, by utilizing the sun and employing specific techniques, navigators can accurately determine their longitude at sea. The method of using the sun to determine longitude is known as the sun's meridian passage. This technique involves measuring the time it takes for the sun to cross the observer's meridian, which is an imaginary line running from the North Pole to the South Pole, passing through the observer's location. By comparing this time with a known reference point, such as Greenwich Mean Time (GMT), navigators can calculate their longitude. To begin the process, the navigator must have an accurate timekeeping device, such as a chronometer or a reliable ship's clock. It is crucial to ensure that the timekeeping device is set to GMT or another known reference time. The navigator then measures the exact moment when the sun reaches its highest point in the sky, known as local apparent noon. This can be determined by observing the sun's altitude using a sextant or other navigational instrument. Once the local apparent noon is determined, the navigator notes the time indicated by the timekeeping device. This time is then compared to the GMT or reference time. The difference between the two times represents the time it takes for the sun to travel from the observer's meridian to the reference meridian. Since the Earth rotates 360 degrees in 24 hours, each hour represents 15 degrees of longitude. Therefore, for every hour difference between the local apparent noon and the reference time, the navigator can calculate their longitude by multiplying the hour difference by 15. For example, if the local apparent noon occurs 2 hours after the reference time, the navigator's longitude would be 30 degrees west of the reference meridian. Conversely, if the local apparent noon occurs 2 hours before the reference time, the navigator's longitude would be 30 degrees east of the reference meridian. It is important to note that the sun's meridian passage method is most accurate when the observer is near the equator. As the observer moves closer to the poles, the sun's path across the sky becomes more curved, making the calculations more complex. Additionally, factors such as atmospheric conditions, the accuracy of the timekeeping device, and the navigator's ability to precisely measure the local apparent noon can affect the accuracy of the longitude determination. To enhance the accuracy of using the sun to determine longitude, navigators often employ additional techniques. One such technique is known as the time sight. This method involves taking multiple altitude measurements of the sun throughout the day and comparing them to a known reference altitude. By analyzing the differences in altitude and the corresponding times, navigators can refine their longitude calculations. Another technique is known as the sun's azimuth. This method involves measuring the sun's azimuth, which is its angular distance from true north or south. By comparing the observed azimuth with a known reference azimuth, navigators can further refine their longitude calculations. In conclusion, while determining longitude using celestial navigation can be challenging, the sun's meridian passage method provides a reliable means of calculating longitude at sea. By accurately measuring the time of the sun's local apparent noon and comparing it to a known reference time, navigators can determine their longitude with a reasonable degree of accuracy. By combining this method with other techniques such as time sight and sun's azimuth, navigators can further refine their longitude calculations and ensure accurate navigation while at sea. 5.3 Using the moon to determine longitude. The moon has been a valuable celestial body for navigators throughout history. Its position and movement can be used to determine longitude, providing crucial information for accurate navigation. While determining longitude solely by the moon can be challenging, it can be a useful tool when combined with other celestial bodies and navigational techniques. The moon's role in celestial navigation. The moon's position in the sky changes noticeably over short periods, making it an excellent reference point for determining longitude. Unlike stars, which appear fixed in the celestial sphere, the moon's motion can be observed and measured more easily. By comparing the observed position of the moon with its predicted position, navigators can calculate their longitude. Lunar distance method. One of the primary methods for using the moon to determine longitude is the lunar distance method. This method involves measuring the angular distance between the moon and another celestial body, such as a star or planet, at a specific time. By comparing this measurement with the predicted lunar distance for that time and location, navigators can calculate their longitude. To use the lunar distance method effectively, navigators need accurate predictions of the moon's position and the positions of other celestial bodies. Navigational almanacs and star charts provide this information, allowing navigators to make precise calculations. Additionally, accurate timekeeping devices are essential for synchronizing observations with predicted positions. The process of determining longitude with the moon. To determine longitude using the moon, navigators follow these steps. Prepare. Obtain accurate predictions of the moon's position and the positions of other celestial bodies from navigational almanacs and star charts. Ensure that the timekeeping devices are synchronized with the predicted time. Observe. Select a suitable celestial body, such as a star or planet, and measure the angular distance between it and the moon using a sextant or octant. Record the time of the observation accurately. Calculate. Consult the navigational almanac to find the predicted lunar distance for the observed time and location. Calculate the difference between the observed lunar distance and the predicted lunar distance. Determine longitude. Using the calculated difference in lunar distance, refer to specialized tables or formulas to convert the difference into a longitude value. This value represents the difference between the observer's location and the reference location used for the predictions. Apply corrections. Consider applying corrections for factors such as instrument errors, atmospheric conditions, and any other known sources of error. These corrections help refine the accuracy of the calculated longitude. Repeat. To increase accuracy, repeat the observation and calculation process multiple times, ideally with different celestial bodies. Taking multiple observations and averaging the results can help minimize errors and provide a more reliable longitude determination. Challenges and limitations. While using the moon to determine longitude can be effective, it does come with some challenges and limitations. The moon's motion is relatively fast compared to other celestial bodies, requiring precise timing and observation. Additionally, the moon's brightness can make it difficult to measure the exact position of nearby stars or planets accurately. Furthermore, weather conditions and atmospheric refraction can affect the accuracy of observations. Cloud cover, haze, or other atmospheric disturbances can obstruct the view of the moon and other celestial bodies, making it challenging to obtain reliable measurements. Combining moon observations with other celestial bodies. To overcome the limitations of using the moon alone, navigators often combine moon observations with observations of other celestial bodies. By taking multiple measurements and comparing them, navigators can increase the accuracy of their longitude calculations. For example, navigators can use the moon in conjunction with the sun or stars to determine longitude. By measuring the angular distance between the moon and the sun or specific stars, navigators can triangulate their position more accurately. This method, known as the lunar solar distance, or lunar star distance, method, provides a more robust approach to determining longitude. Conclusion. Using the moon to determine longitude is a valuable technique in celestial navigation. While it presents challenges and limitations, combining moon observations with other celestial bodies can enhance accuracy. By following the lunar distance method and employing precise observation techniques, navigators can utilize the moon's position and movement to navigate with confidence and accuracy. 5.4 Using other celestial bodies to determine longitude. While the sun and the moon are commonly used celestial bodies for determining longitude, there are other celestial bodies that can also be utilized in celestial navigation. These celestial bodies include planets, stars, and even comets. Each of these celestial bodies has its own unique characteristics and can provide valuable information for determining longitude. Planets. Planets, such as Venus, Mars, Jupiter, and Saturn, can be used to determine longitude in a similar way to the sun and the moon. By observing the position of a planet in the sky and comparing it to its predicted position, navigators can calculate their longitude. However, using planets for celestial navigation requires more precise calculations and accurate predictions due to their relatively fast movement across the celestial sphere. Stars. Stars are another important celestial body for determining longitude. Unlike the sun and the moon, stars are fixed in their positions relative to each other, making them reliable reference points. By measuring the angle between a known star and the horizon, navigators can determine their latitude. However, determining longitude using stars requires more complex calculations. One method of using stars for longitude determination is by measuring the time it takes for a star to cross the observer's meridian. This method, known as the time sight, involves observing a star as it passes directly overhead and recording the exact time of the observation. By comparing this time with the predicted time of the star's meridian passage, navigators can calculate their longitude. Another method, known as star altitude, involves measuring the angle between a star and the horizon at a specific time. By comparing this angle with the predicted angle for a given location and time, navigators can determine their longitude. This method requires accurate timekeeping and precise measurements. Comets. Although less commonly used, comets can also be utilized for determining longitude. Comets are celestial objects that consist of a nucleus of ice and dust. They often have a distinct and visible tail, making them easily identifiable. By observing the position of a comet in the sky and comparing it to its predicted position, navigators can calculate their longitude. However, due to the unpredictable nature of comets, this method may not always be reliable. Challenges and considerations. Using other celestial bodies for determining longitude presents its own set of challenges and considerations. Unlike the sun and the moon, which are relatively bright and easily visible, planets, stars, and comets may require more advanced navigational instruments, such as telescopes, to accurately observe and measure their positions. Additionally, accurate predictions and ephemeris data for these celestial bodies are crucial for precise calculations. Furthermore, weather conditions and atmospheric disturbances can affect the visibility of these celestial bodies, making it challenging to obtain accurate measurements. Light pollution from cities and other sources can also hinder the visibility of stars and other celestial bodies, especially in urban areas. Conclusion. While the Sun and the Moon are the primary celestial bodies used for determining longitude in celestial navigation, other celestial bodies such as planets, stars, and comets can also be utilized. Each of these celestial bodies offers its own unique advantages and challenges. Navigators must have a thorough understanding of the characteristics and behaviors of these celestial bodies, as well as the necessary tools and calculations required to accurately determine longitude. By incorporating these additional celestial bodies into their navigational toolkit, sailors and explorers can enhance their ability to navigate the vast oceans and explore the world with confidence. 6. Correcting for navigational errors. 6.1 Understanding navigational errors. Navigating by the stars is a fascinating and ancient method of determining one's position on Earth. However, like any navigational technique, it is not without its challenges and potential errors. Understanding these errors is crucial for accurate celestial navigation. In this section, we will explore the various navigational errors that can occur during celestial navigation and how to mitigate them. Sources of navigational errors. Navigational errors can arise from a variety of sources, including instrumental errors, atmospheric conditions, and human factors. It is important to be aware of these potential errors and take appropriate measures to correct them. Instrumental errors. Instrumental errors can occur due to inaccuracies or malfunctions in the navigational instruments used for celestial navigation. The most common instrument used in celestial navigation is the sextant, which measures the angle between a celestial body and the horizon. However, even the most well-calibrated sextant can introduce errors. One common instrumental error is the index error, which occurs when the sextant's index mirror is not properly aligned. This can lead to incorrect angle measurements. To correct for index error, navigators must determine the magnitude and direction of the error and apply the appropriate correction. Another instrumental error is the horizon dip correction. When taking celestial sights, navigators often use the visible horizon as a reference point. However, the visible horizon is slightly below the true horizon due to the Earth's curvature. This difference must be accounted for by applying a dip correction to the measured angle. Atmospheric conditions. Atmospheric conditions can also introduce errors in celestial navigation. The most significant atmospheric error is known as refraction. Refraction occurs when light passes through the Earth's atmosphere and is bent, causing celestial bodies to appear higher in the sky than they actually are. This can lead to errors in angle measurements. To correct for refraction, navigators must apply a refraction correction to the measured angle. The magnitude of the correction depends on various factors, including the altitude of the celestial body and the atmospheric conditions at the time of observation. Human factors. Human factors can also contribute to navigational errors during celestial navigation. These errors can arise from a lack of experience, improper technique, or simple mistakes in calculations. It is essential for navigators to be well-trained and knowledgeable in celestial navigation techniques to minimize human errors. One common human error is known as parallax error. Parallax error occurs when the navigator's eye is not aligned with the index mirror of the sextant, resulting in an incorrect angle measurement. To avoid parallax error, navigators must ensure proper alignment of their eye with the index mirror. Mitigating navigational errors. While navigational errors are inevitable to some extent, there are several strategies and techniques to mitigate their impact on celestial navigation accuracy. Applying corrections for altitude and azimuth. To correct for instrumental errors, navigators must apply appropriate corrections for altitude and azimuth. Altitude correction involves adjusting the measured angle to account for index error, dip correction, and refraction. Azimuth correction, on the other hand, compensates for errors in the alignment of the sextant's azimuth scale. By carefully applying these corrections, navigators can significantly improve the accuracy of their celestial navigation calculations. Compensating for instrument errors. Regular calibration and maintenance of navigational instruments are essential to minimize instrumental errors. Navigators should ensure that their sextants are properly aligned, and any index errors are determined and corrected. Additionally, periodic checks and adjustments should be made to the azimuth scale to maintain accuracy. Accounting for atmospheric conditions. To account for atmospheric conditions, navigators must apply refraction corrections based on the altitude of the celestial body and the prevailing atmospheric conditions. It is important to consult accurate and up-to-date tables or formulas to determine the appropriate refraction correction for each observation. Continuous practice and training. Navigating by the stars is a skill that requires practice and experience. Regular training and practice sessions can help navigators refine their techniques, improve their accuracy, and minimize human errors. By continuously honing their skills, navigators can become proficient in celestial navigation and reduce the likelihood of errors. Conclusion. Understanding navigational errors is crucial for successful celestial navigation. By being aware of potential errors arising from instrumental inaccuracies, atmospheric conditions, and human factors, navigators can take appropriate measures to mitigate these errors. Applying corrections for altitude and azimuth, compensating for instrument errors, accounting for atmospheric conditions, and continuous practice and training are all essential in ensuring accurate celestial navigation. With a thorough understanding of navigational errors and the necessary corrective measures, navigators can confidently navigate by the stars and explore the wonders of celestial navigation. 6.2 Applying corrections for altitude and azimuth. Once you have determined the altitude and azimuth of a celestial body, such as the sun or a star, during celestial navigation, it is important to apply corrections to these measurements to ensure accurate calculations. Altitude and azimuth corrections account for various factors that can affect the accuracy of your celestial navigation calculations. In this section, we will explore the different types of corrections and how to apply them effectively. Altitude corrections. Altitude corrections are adjustments made to the measured altitude of a celestial body to account for several factors, including the observer's position, the Earth's atmosphere, and the instrument used for measurement. By applying these corrections, you can obtain a more accurate value for the celestial body's true altitude. Dip correction. One of the most significant altitude corrections is the dip correction. Dip correction compensates for the height of the observer's eye above the surface of the water when navigating at sea. Since celestial navigation is often used in marine environments, this correction is crucial to ensure accurate calculations. To apply the dip correction, you need to determine the height of your eye above the waterline and consult the appropriate tables or formulas to calculate the correction value. The dip correction is subtracted from the measured altitude when the celestial body is above the horizon. Refraction correction. Refraction is the bending of light as it passes through the Earth's atmosphere. This bending causes celestial bodies to appear higher in the sky than they actually are. To account for refraction, a refraction correction is applied to the measured altitude. The amount of refraction varies depending on several factors, including the altitude of the celestial body and atmospheric conditions. Refraction tables or formulas can be used to determine the correction value, which is typically added to the measured altitude. Parallax correction. Parallax is the apparent shift in the position of a celestial body due to the observer's location on Earth. This correction is necessary when using a celestial body that is relatively close to the Earth, such as the Moon or some planets. To apply the parallax correction, you need to know the distance between the observer and the celestial body. This distance can be obtained from navigational almanacs or online resources. The parallax correction is subtracted from the measured altitude. Azimuth corrections. Azimuth corrections are adjustments made to the measured azimuth of a celestial body to account for factors such as the observer's position and the instrument used for measurement. These corrections ensure that the calculated azimuth accurately represents the true direction of the celestial body. Index correction. The index correction compensates for any error in the reading of the instrument's index mirror. It is determined by comparing the instrument's reading with a known reference point, such as a landmark or another celestial body. The index correction is added or subtracted from the measured azimuth, depending on the instrument's design. Instrumental error correction. Instruments used for celestial navigation, such as sextants, may have inherent errors that can affect the accuracy of azimuth measurements. These errors can be caused by imperfections in the instrument's construction or the observer's technique. To correct for instrumental errors, it is essential to determine the magnitude and direction of the error. This can be done through careful calibration and repeated measurements. The correction value is then applied to the measured azimuth to obtain the corrected value. Magnetic variation correction. Magnetic variation, also known as magnetic declination, is the angle between true north and magnetic north. Since celestial navigation relies on true north as a reference, it is necessary to correct for magnetic variation when using a magnetic compass. To apply the magnetic variation correction, you need to know the value of the magnetic variation for your location and the date of observation. This information can be obtained from navigational charts or online resources. The correction value is added or subtracted from the measured azimuth, depending on the direction of magnetic variation. Conclusion. Applying corrections for altitude and azimuth is a crucial step in celestial navigation. By accounting for factors such as dip, refraction, parallax, index error, instrumental error, and magnetic variation, you can ensure the accuracy of your calculations. These corrections allow you to obtain precise values for the altitude and azimuth of celestial bodies, enabling you to determine your position accurately and navigate with confidence. 6.3 Compensating for instrument errors. In celestial navigation, accurate and reliable instruments are essential for obtaining precise measurements of celestial bodies. However, like any other navigational tools, these instruments are prone to errors. Instrument errors can arise from various factors such as mechanical imperfections, calibration issues, or even human error. To ensure accurate celestial navigation, it is crucial to understand and compensate for these instrument errors. Sources of instrument errors. Before delving into the methods of compensating for instrument errors, it is important to identify the potential sources of these errors. Here are some common sources of instrument errors in celestial navigation. 1. Index error. The index error refers to the misalignment of the index mirror or index arm of a sextant or octant. This misalignment can cause the observed celestial body to appear higher or lower than its actual position, leading to inaccurate measurements. 2. Arc error. Arc error occurs when the arc of a sextant or octant is not perfectly calibrated. This can result in incorrect angular measurements, leading to errors in determining the altitude of celestial bodies. 3. Collimation error. Collimation error refers to the misalignment of the optical components of a sextant or octant. This misalignment can cause the observed celestial body to appear displaced from its true position, resulting in errors in azimuth measurements. 4. Parallax error. Parallax error occurs when the observer's eye is not properly aligned with the sighting mechanism of the instrument. This misalignment can cause the observed celestial body to appear shifted, leading to errors in both altitude and azimuth measurements. 5. Refraction error. Refraction error is caused by the bending of light as it passes through the Earth's atmosphere. This bending can cause celestial bodies to appear higher or lower than their actual positions, resulting in errors in altitude measurements. 6. Personal error. Personal error refers to errors introduced by the observer due to improper technique or judgment. This can include errors in reading the instrument, estimating angles, or making adjustments. Compensating for instrument errors. To compensate for instrument errors in celestial navigation, several techniques and procedures can be employed. These methods aim to minimize or eliminate the impact of instrument errors on the accuracy of celestial observations. Here are some common techniques used to compensate for instrument errors. 1. Index correction. Index correction involves determining and applying a correction factor to account for the index error of the instrument. This correction factor is typically obtained by comparing the observed altitude of a celestial body with its known or calculated altitude. By applying the index correction, the observed altitude can be adjusted to its true value. 2. Arc correction. Arc correction is used to compensate for arc error in the sextant or octant. This correction involves applying a correction factor to the measured angle based on the known or calculated arc error. By applying the arc correction, the measured angle can be adjusted to its true value. 3. Collimation correction. Collimation correction is employed to compensate for collimation error in the instrument. This correction involves applying a correction factor to the observed azimuth based on the known or calculated collimation error. By applying the collimation correction, the observed azimuth can be adjusted to its true value. 4. Parallax correction. Parallax correction is used to compensate for parallax error in the instrument. This correction involves adjusting the observed altitude and azimuth based on the observer's position and the known or calculated parallax. By applying the parallax correction, the observed celestial body's position can be adjusted to its true position. 5. Refraction correction. Refraction correction is employed to compensate for the bending of light caused by atmospheric refraction. This correction involves applying a correction factor to the observed altitude based on the known or calculated refraction. By applying the refraction correction, the observed altitude can be adjusted to its true value. 6. Personal error minimization. To minimize personal errors, it is essential to ensure proper training and technique in using celestial navigation instruments. This includes proper instrument handling, accurate reading of scales, precise estimation of angles, and consistent adjustment procedures. Regular practice and experience can help reduce personal errors and improve the accuracy of celestial observations. Importance of instrument calibration. In addition to compensating for instrument errors, regular calibration of celestial navigation instruments is crucial. Calibration involves verifying and adjusting the instrument's components to ensure their accuracy and reliability. Proper calibration helps maintain the instrument's performance and minimizes errors in celestial observations. Calibration should be performed periodically and whenever there is a suspicion of instrument error. It involves checking the alignment of mirrors, verifying the accuracy of scales and verniers, and ensuring the smooth operation of moving parts. Calibration can be done using known reference objects or by comparing the instrument's readings with those of a calibrated instrument. By regularly calibrating celestial navigation instruments, navigators can ensure the accuracy of their measurements and improve the reliability of their celestial observations. This, in turn, enhances the overall accuracy of celestial navigation and contributes to safer and more efficient voyages. In conclusion, compensating for instrument errors is a critical aspect of celestial navigation. By understanding the sources of instrument errors and employing appropriate compensation techniques, navigators can obtain accurate and reliable measurements of celestial bodies. Regular calibration of instruments further enhances the accuracy of celestial observations. By mastering the art of compensating for instrument errors, navigators can confidently navigate by the stars and unlock the wonders of celestial navigation. 6.4 Accounting for atmospheric conditions. Navigating by the stars is a fascinating and ancient practice that has been used by sailors, explorers, and astronomers for centuries. However, one of the challenges faced by celestial navigators is the effect of atmospheric conditions on their observations. The Earth's atmosphere can introduce various distortions and obstructions that can affect the accuracy of celestial navigation. In this section, we will explore the different atmospheric conditions that navigators need to account for and the techniques they use to mitigate their impact. Refraction. One of the most significant atmospheric effects on celestial navigation is refraction. Refraction occurs when light passes through the Earth's atmosphere and is bent due to the variation in air density. This bending of light can cause celestial bodies to appear higher in the sky than they actually are. The amount of refraction depends on several factors, including the altitude of the celestial body and the atmospheric conditions. To account for refraction, navigators apply a correction to the observed altitude of a celestial body. This correction is typically obtained from tables or formulas that take into account the altitude and the atmospheric conditions at the time of observation. By applying the appropriate correction, navigators can obtain a more accurate measurement of the celestial body's true altitude. Atmospheric extinction. Another atmospheric condition that celestial navigators must consider is atmospheric extinction. Atmospheric extinction refers to the gradual decrease in the intensity of light as it passes through the Earth's atmosphere. This decrease in light intensity can make celestial bodies appear dimmer and less visible, especially near the horizon. To compensate for atmospheric extinction, navigators often make observations of celestial bodies when they are at a higher altitude in the sky. By choosing celestial bodies that are higher above the horizon, navigators can minimize the impact of atmospheric extinction and obtain more reliable measurements. Scintillation. Scintillation, also known as twinkling, is a phenomenon caused by the Earth's atmosphere that causes celestial bodies to appear to flicker or twinkle. Scintillation is primarily caused by the turbulence in the atmosphere, which causes the light from the celestial body to be refracted in different directions. While scintillation can be visually captivating, it can also introduce errors in celestial navigation. The apparent movement of a celestial body due to scintillation can make it challenging to obtain accurate measurements of its position. To mitigate the effects of scintillation, navigators often take multiple observations of the same celestial body and average the results to obtain a more reliable measurement. Weather conditions. Weather conditions, such as clouds, fog, and haze, can significantly impact celestial navigation. These conditions can obstruct the view of celestial bodies, making it impossible to make accurate observations. In such cases, navigators must rely on other navigational methods or wait for the weather to clear before continuing their celestial navigation. In addition to obstructing the view, weather conditions can also affect the accuracy of celestial navigation instruments. Moisture, temperature changes, and other atmospheric factors can impact the performance of instruments such as sextants and chronometers. Navigators must take extra care to protect their instruments from adverse weather conditions and make any necessary adjustments or corrections. Predicting and monitoring atmospheric conditions. To account for atmospheric conditions, navigators must have a good understanding of the current and predicted weather conditions. They rely on weather forecasts, meteorological data, and their own observations to assess the atmospheric conditions that may affect their celestial navigation. Navigators also monitor the atmospheric conditions during their observations. They pay attention to changes in visibility, cloud cover, and other weather indicators that may impact the accuracy of their measurements. By continuously monitoring the atmospheric conditions, navigators can make informed decisions about the reliability of their celestial observations and take appropriate corrective actions if necessary. Conclusion. Accounting for atmospheric conditions is an essential aspect of celestial navigation. By understanding and compensating for the effects of refraction, atmospheric extinction, scintillation, and weather conditions, navigators can improve the accuracy of their celestial observations. While atmospheric conditions can introduce challenges, skilled celestial navigators have developed techniques and strategies to navigate the vast oceans and explore the unknown using the stars as their guide. 7. Advanced celestial navigation techniques. 7.1 Using planetary positions for navigation. Navigating by the stars has been a reliable method for centuries, allowing sailors and explorers to determine their position on Earth's surface. While stars have been the primary celestial bodies used for navigation, planets also play a significant role in celestial navigation. In this section, we will explore how planetary positions can be used for navigation and the techniques involved. Planets, such as Venus, Mars, Jupiter, and Saturn, are easily visible in the night sky and can serve as valuable navigational aids. Unlike stars, which appear fixed in the sky, planets exhibit apparent motion due to their orbits around the Sun. This motion can be observed and used to determine a navigator's position. One of the primary techniques for using planetary positions in navigation is known as planetary observation. This involves observing the position of a planet relative to the background stars and comparing it to a known reference point. By measuring the angle between the planet and a reference star, navigators can calculate their latitude and longitude. To use planetary positions effectively, navigators must have accurate information about the planet's position at a specific time. Navigational almanacs and ephemerides provide this information, listing the positions of celestial bodies at regular intervals. These references are essential for celestial navigators, as they allow them to predict the positions of planets accurately. When using planetary positions for navigation, it is crucial to consider the planet's altitude and azimuth. The altitude is the angle between the observer's horizon and the planet, while the azimuth is the angle between the observer's north reference point and the planet. By measuring these angles, navigators can determine their position relative to the planet. To calculate latitude using planetary positions, navigators measure the altitude of the planet when it is at its highest point in the sky. This is known as the planet's meridian passage. By comparing the observed altitude with the predicted altitude from the almanac, navigators can determine their latitude. Longitude determination using planetary positions is a more complex process. It involves measuring the time it takes for a planet to cross the observer's meridian. This time, known as the planet's meridian transit time, can be compared to the predicted transit time from the almanac. By knowing the difference in time between the observed and predicted transit times, navigators can calculate their longitude. It is important to note that using planetary positions for navigation requires precise timekeeping. Accurate time is necessary to determine the planet's meridian passage and transit time accurately. Navigators must have reliable timekeeping devices, such as chronometers or accurate clocks, to ensure the accuracy of their calculations. In addition to planetary observation, another technique that utilizes planetary positions is known as planetary conjunction. This occurs when two or more planets appear close together in the sky. By observing and measuring the angles between the planets, navigators can determine their position. Planetary conjunctions provide navigators with an opportunity to obtain a fix on their position. By comparing the observed angles between the planets with the predicted angles from the almanac, navigators can calculate their latitude and longitude. This technique can be particularly useful when other celestial bodies are not visible or when there is limited visibility due to weather conditions. While using planetary positions for navigation can be effective, it is essential to consider the limitations of this method. Planetary positions are subject to change due to their orbital motion, and accurate predictions require up-to-date information from navigational references. Additionally, weather conditions and visibility can affect the accuracy of observations. Despite these limitations, the use of planetary positions for navigation has been a valuable tool throughout history. Navigators have relied on the predictable motion of planets to determine their position accurately. Today, with advancements in technology and the availability of precise navigational data, the use of planetary positions continues to be a viable option for celestial navigation. In conclusion, planetary positions can be used effectively for navigation, providing navigators with valuable information about their latitude and longitude. By observing and measuring the positions of planets relative to the background stars, navigators can calculate their position accurately. However, it is crucial to have accurate navigational references, precise timekeeping devices, and consider the limitations of this method. With proper knowledge and practice, using planetary positions for navigation can be a reliable and fascinating aspect of celestial navigation. 7.2 Using stellar parallax for navigation. Stellar parallax is a technique used in celestial navigation to determine the distance between celestial objects and the observer. It is based on the principle of triangulation, where the observer measures the apparent shift in position of a celestial object against the background of more distant stars. By comparing this shift with known values, navigators can calculate their position accurately. Understanding stellar parallax. Stellar parallax is caused by the motion of the Earth around the Sun. As the Earth orbits the Sun, the position of nearby stars appears to shift slightly against the background of more distant stars. This shift is measured in angular units, such as arcseconds or arcminutes. To understand stellar parallax, imagine holding your finger at arm's length and looking at it with one eye closed. Now, switch eyes and notice how your finger appears to shift against the background. This shift is similar to what happens with stars when observed from different positions on Earth's orbit. Measuring stellar parallax. To measure stellar parallax accurately, navigators use specialized instruments such as sextants or octants. These instruments allow them to measure the angle between the observed celestial object and a reference point, such as the horizon or another celestial body. The process of measuring stellar parallax involves the following steps. Select a suitable celestial object. Navigators choose a star or planet that is relatively close to the observer's position. Stars with larger parallax angles are preferred for more accurate measurements. Measure the angle. Using a sextant or octant, the navigator measures the angle between the celestial object and a reference point. This angle is known as the parallax angle. Calculate the distance. By knowing the parallax angle and the baseline distance between the observer's positions, navigators can calculate the distance to the celestial object using trigonometry. Determine the position. Once the distance to the celestial object is known, navigators can use this information, along with other celestial observations, to determine their position on Earth accurately. Limitations and challenges. While stellar parallax is a valuable technique for celestial navigation, it has some limitations and challenges. Small parallax angles. Most stars have very small parallax angles, making them challenging to measure accurately. This limitation restricts the use of stellar parallax to relatively close celestial objects. Instrument precision. The accuracy of the measurements depends on the precision of the instruments used. Any errors or inaccuracies in the instruments can affect the calculated distances. Atmospheric conditions. Atmospheric conditions, such as turbulence or haze, can distort the observed positions of celestial objects, making it difficult to measure parallax accurately. Time constraints. Stellar parallax measurements require precise timing to account for the Earth's motion. Navigators must ensure that their observations are made at the correct time to obtain accurate results. Despite these challenges, stellar parallax remains a valuable technique in celestial navigation, especially for determining the distances to nearby stars and planets. Practical applications. Stellar parallax has several practical applications in celestial navigation. Determining distances. By measuring the parallax angles of nearby stars, astronomers can calculate their distances from Earth. This information helps in understanding the scale and structure of the universe. Stellar classification. Stellar parallax is used to determine the luminosity and size of stars. By combining parallax measurements with other observational data, astronomers can classify stars into different categories based on their properties. Spacecraft navigation. Stellar parallax is used in spacecraft navigation to determine the position and orientation of the spacecraft relative to distant stars. This information is crucial for accurate trajectory calculations and course corrections. Astrometry. Astrometry is the branch of astronomy that deals with the precise measurement of the positions and motions of celestial objects. Stellar parallax plays a significant role in astrometry, allowing astronomers to create detailed star catalogs and track the movements of celestial bodies. Conclusion. Stellar parallax is a powerful technique in celestial navigation that allows navigators to determine the distances to celestial objects accurately. By measuring the apparent shift in position of nearby stars against the background of more distant stars, navigators can calculate their position on Earth with great precision. Despite its limitations and challenges, stellar parallax remains an essential tool in understanding the universe and navigating through the vastness of space. 7.3 Using time in celestial navigation. Time plays a crucial role in celestial navigation. By accurately measuring the time of celestial events, navigators can determine their position on Earth. This section explores the relationship between time and celestial navigation and how it is used to calculate latitude and longitude. The importance of time in celestial navigation. In celestial navigation, time serves as a fundamental reference point for calculating the position of celestial bodies. The Earth rotates on its axis, completing a full rotation in 24 hours, resulting in the cycle of day and night. This rotation allows us to measure time using various devices such as clocks and watches. The relationship between time and celestial events. Celestial events, such as the rising and setting of celestial bodies, occur at specific times and locations. By observing these events and recording the corresponding time, navigators can make accurate calculations to determine their position. Solar noon. One of the most significant celestial events is solar noon, which is when the sun reaches its highest point in the sky. At this moment, the sun is directly overhead at the observer's location, indicating that they are on the meridian line. By measuring the time of solar noon and knowing the observer's longitude, it is possible to calculate the observer's position accurately. Local apparent noon. Local apparent noon is the time when the sun is highest in the sky at a specific location. Unlike solar noon, local apparent noon can vary from one location to another due to the Earth's irregular orbit and axial tilt. By accurately measuring the time of local apparent noon and comparing it to the time of solar noon at a reference location, navigators can determine their longitude. Star culminations. Stars also play a crucial role in celestial navigation. As the Earth rotates, stars appear to move across the sky. Each star has a specific culmination point, which is the highest point it reaches in its arc across the sky. By measuring the time of star culminations and knowing the observer's latitude, navigators can determine their longitude. Timekeeping devices in celestial navigation. Accurate timekeeping is essential in celestial navigation. Historically, navigators used various timekeeping devices to measure time, such as hourglasses, pendulum clocks, and chronometers. Today, highly accurate atomic clocks are used for precise time measurements. Calculating latitude using time. Time can be used to calculate latitude in celestial navigation. By observing the altitude of celestial bodies at specific times, navigators can determine their latitude. Using the sun. During the day, the sun's altitude can be measured using a sextant or other navigational instruments. By comparing the measured altitude with the sun's declination, its angular distance north or south of the celestial equator, navigators can calculate their latitude. Using stars. At night, navigators can use the altitude of specific stars to determine their latitude. By measuring the altitude of a star and comparing it to its known declination, they can calculate their latitude accurately. Calculating longitude using time. Determining longitude using time is a more complex process in celestial navigation. However, by accurately measuring the time of specific celestial events, navigators can calculate their longitude. Using the sun. By measuring the time of local apparent noon and comparing it to the time of solar noon at a reference location, such as Greenwich, England, navigators can calculate their longitude. The time difference between the two locations corresponds to the difference in longitude. Using stars. Navigators can also use the time of star culminations to calculate their longitude. By comparing the time of a star's culmination at their location with the time of culmination at a reference location, they can determine the time difference and, consequently, their longitude. The role of time in celestial navigation accuracy. Accurate timekeeping is crucial for precise celestial navigation. Even a small error in time measurement can lead to significant inaccuracies in determining position. Therefore, navigators must ensure that their timekeeping devices are properly calibrated and synchronized with reliable time references. Conclusion. Time is an essential component of celestial navigation. By accurately measuring the time of celestial events and using it in calculations, navigators can determine their latitude and longitude. Timekeeping devices and accurate time references are crucial for the success of celestial navigation. Understanding the relationship between time and celestial navigation allows navigators to navigate the vast oceans and explore the world with confidence and precision. 7.4 Celestial navigation in challenging conditions. Celestial navigation is a remarkable method of finding one's position on Earth by using the stars, planets, and other celestial bodies as reference points. While it is a reliable and accurate technique, there are certain challenging conditions that can make celestial navigation more difficult. In this section, we will explore some of these conditions and discuss strategies for navigating through them. Adverse weather conditions. One of the most common challenges in celestial navigation is adverse weather conditions. Cloudy skies, fog, and heavy rain can obstruct the view of the celestial bodies, making it difficult to take accurate readings. In such situations, it is crucial to have alternative methods of navigation available, such as using a compass, radar, or GPS. These backup systems can help maintain a sense of direction until the weather clears up and celestial observations become possible again. Light pollution. In modern times, light pollution has become a significant challenge for celestial navigation. The bright lights from cities and urban areas can drown out the faint light of the stars, making it difficult to identify and use them for navigation. To overcome this challenge, it is advisable to move away from areas with high light pollution and find a location with a clear view of the night sky. Additionally, using star charts and celestial navigation apps that can filter out light pollution can be helpful in identifying the stars and celestial bodies despite the surrounding brightness. Limited visibility. Navigating during periods of limited visibility, such as during the day or in areas with dense vegetation, can pose challenges for celestial navigation. In these situations, it may be necessary to rely on other navigational techniques, such as dead reckoning or using landmarks, until visibility improves. However, it is still possible to use the sun for navigation during the day by measuring its altitude and calculating the approximate position. This method, known as sunline navigation, can provide a rough estimate of the vessel's position even when celestial bodies are not visible. Southern Hemisphere navigation. Navigating in the Southern Hemisphere presents unique challenges due to the different celestial bodies and reference points available. The North Star, which is a reliable reference point in the Northern Hemisphere, is not visible from the Southern Hemisphere. Instead, navigators in the Southern Hemisphere rely on the Southern Cross constellation and the Magellanic Clouds for orientation. Understanding the specific celestial bodies and their positions in the Southern Hemisphere is essential for accurate celestial navigation in this region. Electronic interference. In today's technologically advanced world, electronic interference can pose challenges to celestial navigation. The presence of electronic devices, such as radios, radar systems, or even smartphones, can interfere with the accuracy of celestial navigation instruments. To mitigate this interference, it is important to keep electronic devices away from the navigational instruments and ensure they are properly shielded. Additionally, regular calibration and maintenance of the instruments can help minimize the impact of electronic interference. Emergency situations. In emergency situations, such as when a vessel is adrift or experiencing equipment failure, celestial navigation can be a vital skill for determining one's position and navigating to safety. However, the stress and urgency of such situations can make celestial navigation more challenging. It is crucial to remain calm and focused, relying on the knowledge and skills acquired through practice and training. Having a well-prepared emergency navigation kit, including essential celestial navigation tools and references, can greatly assist in these situations. Conclusion. Celestial navigation is a versatile and reliable method of finding one's position on Earth, but it does come with its own set of challenges. Adverse weather conditions, light pollution, limited visibility, navigating in the Southern Hemisphere, electronic interference, and emergency situations can all make celestial navigation more difficult. However, with proper preparation, training, and the use of alternative navigation methods when necessary, these challenges can be overcome. Celestial navigation remains a valuable skill for mariners, aviators, and outdoor enthusiasts, providing a connection to the stars and a sense of adventure in navigating the world. 8. Celestial navigation in practice. 8.1 Planning a celestial navigation voyage. Planning a celestial navigation voyage requires careful preparation and consideration of various factors. Navigating by the stars is a complex and precise method of determining position, and it is essential to have a well-thought-out plan before embarking on a celestial navigation journey. In this section, we will explore the key steps involved in planning a celestial navigation voyage. Understanding the basics. Before diving into the planning process, it is crucial to have a solid understanding of the basic principles of celestial navigation. Familiarize yourself with the celestial sphere, celestial coordinates, and the various celestial reference points such as the North Star. Additionally, grasp the concepts of latitude and longitude determination using celestial bodies. This foundational knowledge will form the basis for your planning and execution. Define your objectives. The first step in planning a celestial navigation voyage is to define your objectives. Ask yourself what you hope to achieve through this journey. Are you looking to gain experience in celestial navigation, or are you planning a long-distance voyage using only celestial navigation techniques? Understanding your goals will help shape the rest of your planning process. Select a suitable route. Once you have defined your objectives, it is time to select a suitable route for your celestial navigation voyage. Consider factors such as the distance you wish to travel, the duration of the journey, and the navigational challenges you are willing to undertake. Take into account the availability of celestial bodies for navigation along your chosen route. Some celestial bodies may not be visible or easily identifiable depending on your location and the time of year. Plan your route accordingly to maximize the use of celestial bodies for navigation. Gather navigational resources. Before setting sail, gather all the necessary navigational resources for your celestial navigation voyage. This includes navigational almanacs, star charts, and timekeeping devices. Navigational almanacs provide essential data such as the positions of celestial bodies at specific times, while star charts help identify and locate these bodies in the night sky. Timekeeping devices, such as chronometers or accurate watches, are crucial for determining the time of your celestial observations accurately. Prepare a celestial navigation plan. With your objectives, route, and navigational resources in mind, it is time to prepare a celestial navigation plan. This plan should outline the specific steps you will take to navigate using celestial bodies. Consider the celestial bodies you will use for latitude and longitude determination along your route. Determine the best times for taking celestial observations based on the visibility of these bodies. Calculate the expected altitudes and azimuths of the celestial bodies at those times using the navigational resources at your disposal. This plan will serve as your roadmap during the voyage. Consider contingency plans. While planning your celestial navigation voyage, it is essential to consider contingency plans. Celestial navigation relies heavily on clear skies and good visibility of celestial bodies. However, weather conditions can be unpredictable, and visibility may be compromised. Prepare alternative navigation methods or routes in case celestial navigation becomes challenging or impossible due to adverse weather conditions. This may include using dead reckoning or electronic navigation systems as backups. Familiarize yourself with the equipment. Before setting off on your celestial navigation voyage, take the time to familiarize yourself with the equipment you will be using. Practice using your sextant or octant to take accurate celestial observations. Learn how to read and interpret the navigational almanacs and star charts. Ensure that your timekeeping devices are synchronized and functioning correctly. Familiarity with your equipment will enhance your confidence and efficiency during the voyage. Conduct a trial run. To ensure that your celestial navigation plan is effective, consider conducting a trial run before embarking on your actual voyage. Choose a location where you can practice taking celestial observations and applying the necessary calculations. Evaluate the accuracy of your results and make any necessary adjustments to your plan. This trial run will help identify any potential issues or areas for improvement before setting sail. Seek expert guidance. If you are new to celestial navigation or feel uncertain about any aspect of your planning, consider seeking expert guidance. There are numerous resources available, including books, online courses, and experienced navigators who can provide valuable insights and advice. Engaging with experts in the field will enhance your understanding and confidence in celestial navigation. By following these steps and thoroughly planning your celestial navigation voyage, you will be well prepared to navigate by the stars. Remember to stay adaptable and open to learning throughout your journey. Celestial navigation is a skill that requires practice and experience, and each voyage will contribute to your growth as a celestial navigator. Bon voyage. 8.2 Executing celestial navigation techniques. Once you have planned your celestial navigation voyage and gathered all the necessary tools and resources, it is time to execute the celestial navigation techniques. This section will guide you through the step-by-step process of navigating by the stars. Step 1. Determine the time. Before you can begin celestial navigation, it is crucial to have an accurate measure of time. This can be achieved by using a reliable timekeeping device such as a marine chronometer or a GPS receiver. Ensure that the time is set to the correct time zone and is synchronized with the Universal Time Coordinated (UTC). Step 2. Identify celestial bodies. The next step is to identify the celestial bodies that will be used for navigation. The most commonly used celestial bodies are the Sun, Moon, planets, and stars. Depending on the time of day and your location, certain celestial bodies may be more visible and suitable for navigation than others. Consult a navigational almanac or star chart to determine which celestial bodies are visible in their respective positions. Step 3. Measure altitude and azimuth. To determine your position using celestial navigation, you need to measure the altitude and azimuth of the celestial body you have chosen. Altitude refers to the angle between the celestial body and the horizon, while azimuth represents the angle between the celestial body and a reference point, usually the north. To measure the altitude, use a sextant or octant to align the horizon with the celestial body. Read the angle indicated on the instrument, which will give you the altitude of the celestial body. To measure the azimuth, align the reference point north with the celestial body using the sextant or octant. Read the angle indicated on the instrument, which will give you the azimuth of the celestial body. Step 4. Correct for instrument errors. It is essential to account for any errors or inaccuracies in your navigational instruments. Instrument errors can include index error, dip correction, and personal error. Index error refers to the discrepancy between the actual and indicated position of the index mirror. Dip correction compensates for the height of the observer above sea level. Personal error accounts for any inconsistencies in the way you handle the instrument. To correct for these errors, consult the manufacturer's instructions for your specific instrument. Apply the necessary corrections to ensure accurate measurements of altitude and azimuth. Step 5. Calculate position. Once you have measured the altitude and azimuth of the celestial body and corrected for instrument errors, you can calculate your position using celestial navigation formulas. These formulas take into account the observed altitude, azimuth, time, and the known position of the celestial body at that time. The calculations can be complex, involving trigonometry and spherical geometry. However, with practice and the aid of navigational tables or calculators, you can determine your latitude and longitude based on the celestial observations. Step 6. Plotting the position. After calculating your latitude and longitude, it is time to plot your position on a navigational chart or map. Use a parallel ruler and a dividers to transfer the coordinates onto the chart accurately. Mark your position with a symbol or dot. Step 7. Repeat the process. Celestial navigation is not a one-time measurement. To ensure accuracy and account for any changes in position, it is essential to repeat the process of measuring altitude and azimuth, correcting for instrument errors, calculating position, and plotting the new position at regular intervals. By continuously updating your position, you can track your progress and make any necessary course corrections during your voyage. Step 8. Verify and cross-check. To ensure the accuracy of your celestial navigation, it is crucial to verify and cross-check your position using multiple celestial bodies. By observing and calculating the positions of different celestial bodies simultaneously, you can compare the results and identify any discrepancies or errors. Cross-checking your position with other navigational methods such as dead reckoning or GPS can also provide additional confirmation of your location. Step 9. Maintain a logbook. Throughout your celestial navigation voyage, it is essential to maintain a detailed logbook. Record all the celestial observations, calculations, corrections, and plotted positions. This logbook will serve as a valuable reference for future voyages and troubleshooting any navigational issues. Step 10. Continual practice and improvement. Celestial navigation is a skill that requires continual practice and refinement. The more you practice, the more proficient you will become in executing the techniques and interpreting the celestial observations. Regularly review and update your knowledge of celestial navigation to stay current with advancements in technology and techniques. By following these steps and honing your celestial navigation skills, you can confidently navigate by the stars and embark on exciting voyages with a deep connection to the ancient art of celestial navigation. 8.3 Recording and documenting celestial observations. Recording and documenting celestial observations is a crucial aspect of celestial navigation. By accurately recording your observations, you can ensure the reliability and repeatability of your navigational calculations. In this section, we will explore the importance of recording celestial observations and discuss the various methods and tools used for documentation. Importance of recording celestial observations. Recording celestial observations serves multiple purposes in celestial navigation. Firstly, it allows you to keep a detailed record of the celestial bodies you have observed, their positions, and the time of observation. This information is essential for calculating your position accurately and determining your course. Secondly, documenting celestial observations enables you to review and analyze your data later. By comparing your recorded observations with navigational almanacs and star charts, you can verify the accuracy of your calculations and identify any errors or discrepancies. This process of review and analysis helps refine your skills and improve the accuracy of your celestial navigation. Lastly, recording celestial observations allows you to create a logbook or journal of your celestial journeys. This logbook not only serves as a personal record of your navigational achievements but also becomes a valuable resource for future reference. It can provide insights into your navigational experiences, help you learn from past mistakes, and serve as a guide for future celestial voyages. Methods of recording celestial observations. There are several methods and tools available for recording celestial observations. The choice of method depends on personal preference, the level of detail desired, and the available resources. Here are some commonly used methods. 1. Celestial Observation Logbook. A celestial observation logbook is a dedicated journal specifically designed for recording celestial observations. It typically includes pre-printed fields for recording the date, time, celestial body observed, its position, and any relevant notes or remarks. Using a logbook ensures consistency in recording observations and provides a structured format for easy reference. 2. Navigational Worksheets. Navigational worksheets are useful for recording celestial observations in a more organized and systematic manner. These worksheets often include tables or grids where you can enter the relevant data, such as the date, time, celestial body, altitude, azimuth, and calculated position. Worksheets can be customized to suit your specific needs and can be printed or created digitally for ease of use. 3. Digital apps and software. With the advent of technology, there are now various digital apps and software available for recording and documenting celestial observations. These tools often provide a user-friendly interface where you can input your observations and generate detailed reports or logs. They may also offer additional features such as real-time celestial body tracking, automatic calculations, and integration with other navigational tools. 4. Photography and imaging. Photography and imaging techniques can be used to visually document celestial observations. By capturing images of the night sky or specific celestial bodies, you can create a visual record of your observations. This method is particularly useful for capturing rare or significant celestial events. However, it is important to note that photography alone may not provide the necessary data for navigational calculations and should be used in conjunction with other recording methods. Tips for accurate documentation. To ensure the accuracy and reliability of your recorded celestial observations, consider the following tips. Use a reliable timekeeping device, such as a chronometer or GPS, to record the exact time of observation. Double-check your recorded data for any errors or inconsistencies before proceeding with calculations. Include any relevant environmental conditions, such as weather, visibility, and atmospheric conditions, in your documentation. Maintain a consistent format and style of recording to facilitate easy review and analysis. Regularly review and compare your recorded observations with navigational almanacs, star charts, or other reliable sources to verify their accuracy. Keep your documentation organized and easily accessible for future reference. By following these tips and adopting a disciplined approach to recording and documenting celestial observations, you can enhance the accuracy and reliability of your celestial navigation endeavors. In the next section, we will explore troubleshooting and problem-solving techniques in celestial navigation, helping you overcome challenges that may arise during your celestial journeys. 8.4 Troubleshooting and Problem-Solving in Celestial Navigation. Celestial navigation is a complex and precise method of determining position using celestial bodies. While it is a reliable and time-tested technique, there are certain challenges and problems that navigators may encounter during their celestial navigation journeys. In this section, we will explore some common troubleshooting techniques and problem-solving strategies to help navigators overcome these obstacles and ensure accurate celestial navigation. Identifying and correcting instrument errors. One of the first steps in troubleshooting celestial navigation is to identify and correct any errors that may occur with the navigational instruments. Instruments such as sextants and octants are essential tools for measuring the angles between celestial bodies and the horizon. However, these instruments can be prone to errors due to various factors such as mechanical issues, improper calibration, or user error. To troubleshoot instrument errors, navigators should regularly check and calibrate their instruments to ensure accurate readings. This can be done by comparing the readings of the instrument with known celestial bodies or by using artificial horizons for calibration. If an instrument is found to be consistently producing inaccurate readings, it may need to be repaired or replaced. Compensating for atmospheric conditions. Another challenge in celestial navigation is the impact of atmospheric conditions on celestial observations. Factors such as haze, fog, or cloud cover can obstruct the visibility of celestial bodies, making it difficult to obtain accurate readings. In such situations, navigators need to employ problem-solving techniques to compensate for these atmospheric conditions. One approach is to use multiple observations of different celestial bodies to triangulate the position. By taking readings from several visible celestial bodies and using their intersecting lines of position, navigators can still determine their approximate location, even if the visibility of individual bodies is compromised. Additionally, navigators can make use of celestial bodies that are less affected by atmospheric conditions. For example, the Moon and bright planets like Venus or Jupiter are often visible even in hazy or cloudy conditions. By focusing on these celestial bodies, navigators can still obtain reliable readings and navigate effectively. Dealing with timekeeping errors. Accurate timekeeping is crucial in celestial navigation, as it allows navigators to calculate the position of celestial bodies accurately. However, errors in timekeeping can occur due to various reasons, such as incorrect synchronization of timekeeping devices or inaccuracies in the onboard clocks. To troubleshoot timekeeping errors, navigators should regularly compare their onboard clocks with reliable time sources, such as radio time signals or GPS time. By adjusting their clocks to match these sources, navigators can ensure accurate timekeeping and minimize errors in celestial navigation calculations. Addressing navigational errors. Navigational errors can occur during the process of taking celestial observations and performing calculations. These errors can result from mistakes in recording or transcribing data, inaccuracies in calculations, or misinterpretation of navigational charts or almanacs. To address navigational errors, navigators should adopt a systematic approach to double-check their observations and calculations. This includes verifying the accuracy of recorded data, cross-referencing calculations with established formulas, and carefully reviewing navigational charts and almanacs for any discrepancies. Additionally, navigators should maintain a logbook to record all celestial observations and calculations. This logbook serves as a valuable reference for troubleshooting errors and allows navigators to track their progress and identify any recurring issues. Seeking expert advice and training. In situations where troubleshooting becomes challenging or problems persist, it is advisable for navigators to seek expert advice or additional training. Celestial navigation is a specialized skill that requires a deep understanding of celestial mechanics, navigational techniques, and problem-solving strategies. Navigators can reach out to experienced celestial navigators, join celestial navigation communities, or enroll in advanced celestial navigation courses to enhance their knowledge and skills. These resources provide opportunities to learn from experts, exchange experiences, and gain insights into effective troubleshooting methods. Conclusion. Troubleshooting and problem-solving are integral parts of celestial navigation. By being aware of potential challenges and employing effective strategies, navigators can overcome obstacles and ensure accurate navigation by the stars. Identifying and correcting instrument errors, compensating for atmospheric conditions, addressing timekeeping errors, and double-checking navigational calculations are essential troubleshooting techniques. Additionally, seeking expert advice and training can further enhance navigators' problem-solving abilities. With these strategies in place, navigators can confidently navigate the vast oceans using the celestial bodies as their guide. 9. Celestial navigation in the modern world. 9.1 The role of celestial navigation in modern navigation. Celestial navigation, the art of using celestial bodies to determine position and direction, has a rich history dating back thousands of years. While modern navigation methods such as GPS have largely replaced celestial navigation for most practical purposes, the knowledge and skills associated with celestial navigation still hold great value in certain contexts. In this section, we will explore the role of celestial navigation in modern navigation and its continued relevance in various fields. Celestial navigation in marine navigation. Although GPS has revolutionized marine navigation, celestial navigation remains an important backup method and a valuable skill for sailors and mariners. In remote areas or during long voyages, where GPS signals may be unreliable or unavailable, celestial navigation can provide a reliable means of determining position. Additionally, celestial navigation serves as a valuable tool for verifying the accuracy of GPS readings and detecting any potential errors. Furthermore, celestial navigation offers a sense of tradition and connection to the seafaring past. Many sailors still appreciate the art of celestial navigation as a way to connect with the history of maritime exploration and to develop a deeper understanding of the natural world. It also provides a sense of self-reliance and independence, as sailors can navigate without relying solely on modern technology. Celestial navigation in aviation. While modern aircraft rely heavily on GPS and advanced navigation systems, celestial navigation still plays a role in aviation, particularly in long-range flights and in situations where GPS signals may be disrupted. Celestial navigation can serve as a backup method for determining position and can help pilots verify the accuracy of their GPS readings. In addition, celestial navigation is often taught to pilots as part of their training. It helps them develop a deeper understanding of navigation principles and enhances their overall situational awareness. Pilots who are proficient in celestial navigation can also use it as a tool for celestial orientation, allowing them to identify landmarks and navigate in the absence of other visual references. Celestial navigation in space exploration. Celestial navigation has been an integral part of space exploration since its inception. In the early days of space travel, astronauts used celestial navigation techniques to determine their position and orientation in space. By observing the positions of stars and other celestial bodies, astronauts could accurately navigate their spacecraft and ensure they were on the correct trajectory. Even with the advent of advanced onboard navigation systems, celestial navigation remains an important backup method for space missions. In the vastness of space, where GPS signals are not available, celestial navigation provides a reliable means of determining position and orientation. It also serves as a valuable tool for verifying the accuracy of onboard navigation systems and detecting any potential errors. The future of celestial navigation. While celestial navigation has taken a backseat to modern navigation methods, its importance and relevance persist in various fields. As technology continues to advance, there is still a need for backup navigation methods and the skills associated with celestial navigation. The ability to navigate using the stars provides a sense of self-reliance and independence, and it fosters a deeper understanding of the natural world and our place within it. Furthermore, celestial navigation serves as a reminder of the rich history of human exploration and the ingenuity of our ancestors. It connects us to a time when the stars were our guides and reminds us of the challenges and triumphs of early explorers. By continuing to study and practice celestial navigation, we honor their legacy and keep alive the traditions and knowledge that have shaped our understanding of the world. In conclusion, while modern navigation methods have largely replaced celestial navigation in everyday use, its role in modern navigation should not be underestimated. From marine navigation to aviation and space exploration, celestial navigation continues to play a vital role as a backup method, a tool for verification, and a means of fostering a deeper connection to our past and the natural world. As we navigate the seas, skies, and beyond, the stars remain a timeless guide, reminding us of the enduring value of celestial navigation. 9.2 Celestial navigation in aviation. Celestial navigation, the art of using celestial bodies to determine position and direction, has been a crucial tool for navigators throughout history. While advancements in technology have provided more accurate and efficient methods of navigation, celestial navigation still holds its significance in various fields, including aviation. In this section, we will explore the role of celestial navigation in aviation and how it is utilized in modern aircraft. Celestial navigation in early aviation. In the early days of aviation, before the advent of advanced navigational systems, celestial navigation played a vital role in guiding aircraft across long distances. Pilots relied on celestial bodies, such as the sun, moon, stars, and planets, to determine their position and maintain course accuracy. By measuring the altitude and azimuth of celestial bodies using specialized instruments like sextants, pilots could calculate their latitude and longitude. The importance of celestial navigation in aviation. Even with the introduction of sophisticated navigation systems like GPS, celestial navigation remains relevant in aviation for several reasons. Firstly, it serves as a backup method in case of system failures or malfunctions. In situations where GPS signals are unavailable or compromised, celestial navigation can provide accurate position fixes, ensuring the safety of the aircraft and its occupants. Secondly, celestial navigation enhances pilots' situational awareness. By actively engaging with the celestial sphere and understanding their position relative to celestial bodies, pilots develop a deeper understanding of their surroundings. This heightened awareness can be particularly valuable during long-haul flights or when flying over vast expanses of open water, where visual references may be limited. Modern applications of celestial navigation in aviation. While the use of celestial navigation in aviation has diminished with the rise of advanced technology, it still finds practical applications in certain scenarios. One such application is in long-range oceanic flights, where pilots may encounter areas with limited or no radar coverage. In these situations, celestial navigation can provide valuable position updates, ensuring accurate navigation and preventing potential deviations from the intended flight path. Additionally, celestial navigation can be used to verify the accuracy of other navigation systems. By comparing the position obtained through GPS or inertial navigation systems with the position calculated using celestial observations, pilots can identify any discrepancies and make necessary adjustments to ensure accurate navigation. Training and certification in celestial navigation for pilots. While celestial navigation is not a mandatory skill for pilots in modern aviation, some pilots choose to undergo training and certification in this traditional navigation method. Celestial navigation training typically covers the theoretical concepts, practical techniques, and instrument usage required to perform celestial observations accurately. Pilots interested in celestial navigation can enroll in specialized courses offered by aviation training organizations or seek guidance from experienced navigators. These courses often include hands-on practice with sextants and other navigational instruments, as well as simulated flights to apply celestial navigation techniques in real-world scenarios. Limitations and challenges of celestial navigation in aviation. Despite its advantages, celestial navigation also has limitations and challenges in the aviation context. One significant limitation is the dependence on clear skies and good visibility. Celestial bodies must be visible to obtain accurate observations, making celestial navigation less reliable during adverse weather conditions or in areas with heavy cloud cover. Another challenge is the time and effort required to perform celestial observations accurately. Unlike modern navigation systems that provide instant position updates, celestial navigation involves precise measurements and calculations, which can be time-consuming. Pilots must allocate sufficient time and resources to perform celestial observations effectively, which may not always be feasible during time-sensitive operations. Conclusion. Celestial navigation, although less prevalent in modern aviation, continues to hold its place as a valuable backup and situational awareness tool. While advanced technology has revolutionized navigation in aviation, the knowledge and skills associated with celestial navigation remain relevant and can enhance a pilot's overall navigational proficiency. By understanding the principles and techniques of celestial navigation, pilots can navigate with confidence, even in situations where other navigation systems may be compromised. 9.3 Celestial navigation in space exploration. Celestial navigation, the art of using celestial bodies to determine position and direction, has been a crucial tool for explorers and navigators throughout history. While it has traditionally been used for maritime and aviation purposes, celestial navigation also plays a significant role in space exploration. In the vastness of space, where traditional landmarks and reference points are scarce, celestial navigation provides a reliable method for spacecraft to navigate and orient themselves. The challenges of space navigation. Navigating in space presents unique challenges that require innovative solutions. Unlike on Earth, where landmarks and geographical features can be used as reference points, space is a vast expanse of emptiness. Traditional navigation methods, such as GPS, are not feasible beyond Earth's atmosphere. Therefore, space missions rely heavily on celestial navigation to determine their position and trajectory. Celestial bodies as reference points. In space exploration, celestial bodies such as stars, planets, and moons serve as essential reference points for navigation. Just as sailors use the North Star to determine their latitude, spacecraft can use specific celestial bodies to establish their position and orientation in space. Determining position. To determine their position in space, spacecraft use a combination of celestial bodies and advanced mathematical calculations. By measuring the angles between known celestial bodies and the spacecraft, navigators can triangulate their position. This process is similar to how sailors use the angles between the horizon and celestial bodies to determine their latitude and longitude. Orientation and course corrections. In addition to determining position, celestial navigation is also crucial for orienting spacecraft and making course corrections. By observing the positions of celestial bodies relative to the spacecraft, navigators can adjust their course and ensure they stay on the desired trajectory. This is particularly important for long-duration space missions, where even small deviations from the planned course can have significant consequences. Timekeeping in space. Accurate timekeeping is essential for celestial navigation in space. Just as sailors use chronometers to keep precise time at sea, spacecraft rely on highly accurate atomic clocks to measure time in space. These clocks are crucial for calculating the positions of celestial bodies and making precise navigational calculations. Challenges and limitations. While celestial navigation is a valuable tool for space exploration, it does have its limitations. One significant challenge is the vast distances involved. The positions of celestial bodies can change over time due to their own motion and the motion of the spacecraft. Therefore, constant updates and recalculations are necessary to maintain accurate navigation. Another challenge is the presence of gravitational forces from celestial bodies. These forces can affect the trajectory of spacecraft and introduce additional complexities into the navigation process. Navigators must account for these gravitational influences to ensure accurate positioning and course corrections. Future developments. As space exploration continues to advance, so too will the techniques and technologies used for celestial navigation. Researchers are exploring new methods, such as using pulsars as navigational beacons. Pulsars are highly stable and predictable celestial objects that emit regular pulses of radiation. By measuring the arrival times of these pulses, spacecraft can determine their position with great accuracy. Additionally, advancements in artificial intelligence and machine learning are being applied to celestial navigation. These technologies can analyze vast amounts of data and make real-time navigational decisions, improving the efficiency and accuracy of space missions. Conclusion. Celestial navigation has proven to be an invaluable tool for space exploration. By using celestial bodies as reference points, spacecraft can determine their position, orient themselves, and make course corrections. While there are challenges and limitations to celestial navigation in space, ongoing research and technological advancements are continuously improving its effectiveness. As we venture further into the cosmos, celestial navigation will remain a vital component of our exploration and understanding of the universe. 9.4 The future of celestial navigation. Celestial navigation has a rich history that dates back centuries, but what does the future hold for this ancient practice? In a world dominated by advanced technology and GPS, the role of celestial navigation may seem diminished. However, there are still several reasons why celestial navigation continues to be relevant and why its future remains promising. The resurgence of traditional navigation techniques. While GPS has become the primary method of navigation for most people, there is a growing interest in traditional navigation techniques, including celestial navigation. Many sailors, hikers, and outdoor enthusiasts are rediscovering the art of navigating by the stars as a way to connect with nature and challenge themselves. This resurgence has led to a renewed interest in celestial navigation and a desire to preserve this ancient skill. Backup navigation method. One of the main reasons why celestial navigation will continue to have a place in the future is its reliability as a backup navigation method. While GPS is incredibly accurate and convenient, it is not infallible. Satellites can fail, signals can be disrupted, and batteries can die. In such situations, celestial navigation can serve as a reliable backup, allowing navigators to determine their position and course using the stars, moon, and other celestial bodies. Exploration of remote areas. As humans continue to explore remote and uncharted areas of the world, celestial navigation becomes an invaluable tool. In regions where GPS signals may be weak or non-existent, celestial navigation can provide a means of determining position and direction. This is particularly important for scientific expeditions, research vessels, and adventurers who venture into areas where traditional navigation methods may not be feasible. Space exploration. While celestial navigation has traditionally been used on Earth, its principles are also applicable to space exploration. As humans venture further into space, celestial navigation will play a crucial role in determining the position and trajectory of spacecraft. Just as sailors use the stars to navigate the vast oceans, astronauts will rely on celestial bodies to navigate the vastness of space. The future of celestial navigation may involve advancements in technology specifically designed for space travel, such as improved star trackers and advanced algorithms for calculating positions in zero-gravity environments. Cultural and historical significance. Celestial navigation is not just a practical skill, it also holds cultural and historical significance. It is deeply rooted in the traditions and practices of many seafaring cultures around the world. Preserving and passing on this knowledge ensures that future generations can appreciate the historical importance of celestial navigation and the skills required to navigate without relying solely on technology. Additionally, celestial navigation is often seen as a romantic and poetic way of navigating, connecting people to the beauty of the night sky and the wonders of the universe. Education and research. The future of celestial navigation also lies in education and research. As more people become interested in traditional navigation techniques, there is a need for comprehensive training programs and resources. Celestial navigation courses, workshops, and online resources can help individuals learn and master this ancient skill. Furthermore, ongoing research in the field of celestial navigation can lead to advancements in techniques, instruments, and algorithms, making it more accessible and accurate for future navigators. Environmental considerations. In an era where environmental sustainability is a global concern, celestial navigation offers a navigation method that is completely reliant on natural resources. Unlike GPS, which requires satellites and energy-intensive technology, celestial navigation relies solely on the stars and other celestial bodies. By promoting the use of celestial navigation, we can reduce our dependence on technology that contributes to carbon emissions and environmental degradation. Integration with modern technology. The future of celestial navigation may also involve the integration of modern technology. While celestial navigation is traditionally a manual process, advancements in technology can enhance its accuracy and ease of use. For example, smartphone applications and software programs can assist navigators in identifying celestial bodies, calculating positions, and providing real-time guidance. These technological advancements can make celestial navigation more accessible to a wider audience and encourage its continued use in the modern world. In conclusion, while the dominance of GPS may have overshadowed celestial navigation in recent years, the future of this ancient practice remains bright. Celestial navigation continues to be relevant as a backup navigation method, for exploration in remote areas, and for space travel. Its cultural and historical significance, as well as its environmental sustainability, further contribute to its importance. With ongoing education, research, and integration with modern technology, celestial navigation will continue to thrive and captivate the imaginations of navigators for generations to come. 10. Celestial navigation resources and references. 10.1 Recommended books and publications. Navigating by the stars is a fascinating and complex skill that requires a deep understanding of celestial navigation principles and techniques. To master this ancient art, it is essential to have access to reliable and comprehensive resources that can guide you through the process. In this section, we will explore some recommended books and publications that can serve as valuable references for aspiring celestial navigators. Books on Celestial Navigation. Celestial Navigation for Yachtsmen, by Mary Blewett. This classic book is a must-have for anyone interested in celestial navigation. It provides a clear and practical introduction to the subject, covering topics such as the celestial sphere, sextant usage, and sight reduction methods. The book also includes numerous examples and exercises to help readers apply the concepts in real-world scenarios. The American Practical Navigator, Pub. No. 9 by the National Geospatial Intelligence Agency, also known as BOTIC. This comprehensive reference guide is considered the Bible of navigation. It covers a wide range of topics, including celestial navigation, piloting, electronic navigation, and maritime safety. The book is regularly updated to reflect the latest advancements in navigation technology and techniques. Celestial Navigation in the GPS Age, by John Carl. This book bridges the gap between traditional celestial navigation and modern GPS technology. It explores how celestial navigation can complement and enhance GPS navigation, providing redundancy and a deeper understanding of the principles involved. The book includes practical examples and case studies to illustrate the integration of celestial and electronic navigation. Celestial Navigation, a complete home study course, by David Birch. This comprehensive coursebook is designed for self-study and covers all aspects of celestial navigation in a step-by-step manner. It includes detailed explanations, practical exercises, and practice site forms to help readers develop their skills. The book also provides guidance on using modern tools such as calculators and computers for sight reduction. Celestial Navigation, a practical guide for sailors, by Franna Section OIS Marrier. This practical guide focuses on celestial navigation techniques specifically tailored for sailors. It covers topics such as sight reduction, position fixing, and route planning using celestial bodies. The book also includes tips and tricks for optimizing celestial navigation on sailboats. Publications and periodicals. The Nautical Almanac, published annually, this essential reference provides precise astronomical data for celestial navigation. It includes tables for the positions of celestial bodies, as well as other useful information such as sunrise and sunset times, moon phases, and tidal data. The Nautical Almanac is available in both print and electronic formats. The Sextant Handbook, by Bruce Bauer. This comprehensive guide focuses specifically on the use and calibration of sextants. It covers topics such as sextant types, adjustments, and error corrections. The book also includes practical exercises to help readers improve their sextant skills. Ocean Navigator. This magazine is dedicated to all aspects of offshore navigation, including celestial navigation. It features articles on navigation techniques, equipment reviews, and real-life stories from experienced sailors. Ocean Navigator is a valuable resource for staying up to date with the latest developments in celestial navigation. The Journal of Navigation. This academic journal publishes research articles and papers on various aspects of navigation, including celestial navigation. It covers topics such as navigational algorithms, instrument design, and historical navigation methods. The Journal of Navigation is a valuable resource for those interested in the technical and theoretical aspects of celestial navigation. Online resources. NavList. NavList is an online community dedicated to celestial navigation. It provides a platform for discussions, questions, and sharing of knowledge among celestial navigators of all levels. The website also hosts a wealth of resources, including articles, tutorials, and recommended reading lists. Celestere. Celestere is a website that offers a wide range of celestial navigation resources, including books, calculators, and software. It also provides online courses and workshops for those looking to enhance their celestial navigation skills. National Oceanic and Atmospheric Administration (NOAA). The NOAA website offers a wealth of information on navigation, including celestial navigation. It provides access to online tools, publications, and educational resources related to celestial navigation and other navigation techniques. Royal Institute of Navigation. The Royal Institute of Navigation is a professional organization that promotes the art and science of navigation. Their website offers resources, publications, and information on celestial navigation, as well as other navigation disciplines. These recommended books, publications, and online resources provide a solid foundation for learning and practicing celestial navigation. Whether you are a beginner or an experienced navigator, these references will help you navigate the celestial sphere with confidence and precision. Remember, celestial navigation is a skill that requires practice and continuous learning, so make sure to immerse yourself in these resources and explore the wonders of navigating by the stars. 10.2 Online Resources for Celestial Navigation. In today's digital age, the internet has become an invaluable tool for learning and practicing celestial navigation. There are numerous online resources available that can enhance your understanding of this ancient art and help you navigate by the stars with confidence. Whether you are a beginner or an experienced navigator, these resources offer a wealth of information, tools, and interactive platforms to support your celestial navigation journey. Here are some of the top online resources for celestial navigation. Celestial navigation websites. National Oceanic and Atmospheric Administration (NOAA). The NOAA website provides a comprehensive collection of resources on celestial navigation. It offers tutorials, calculators, and reference materials to help you understand and apply celestial navigation techniques. The site also includes links to navigational charts, almanacs, and other useful tools. Celestial Navigation Net. This website is dedicated to celestial navigation and offers a wide range of resources for both beginners and advanced navigators. It provides tutorials, articles, and interactive tools to help you learn and practice celestial navigation. The site also features a forum where you can connect with other enthusiasts and seek guidance from experienced navigators. The Nautical Almanac. The Nautical Almanac website provides access to the official Nautical Almanac publication, which contains essential data for celestial navigation. It offers daily pages with celestial information, such as the positions of the sun, moon, planets, and stars. The site also includes tutorials and guides on how to use the Nautical Almanac for navigation. Celestere. Celestere is a renowned provider of celestial navigation instruments and resources. Their website offers a variety of tools, including calculators, star charts, and software for celestial navigation. They also provide educational materials, such as books and instructional videos, to help you master the art of celestial navigation. Online courses and tutorials. U.S. Power Squadrons. The U.S. Power Squadrons offer online courses on celestial navigation. These courses are designed for both beginners and experienced navigators and cover topics such as celestial sphere, sight reduction, and plotting. The courses provide interactive lessons, quizzes, and practical exercises to enhance your understanding and skills in celestial navigation. Starpath School of Navigation. The Starpath School of Navigation offers online courses on celestial navigation, taught by experienced navigators. Their courses cover a wide range of topics, including celestial sight reduction, star identification, and practical navigation techniques. The courses include video lectures, interactive exercises, and real-world examples to help you apply celestial navigation in practice. Navathome. Navathome offers an online celestial navigation course that is recognized by the Royal Yachting Association (RIA). The course covers all aspects of celestial navigation, from basic concepts to advanced techniques. It includes interactive lessons, quizzes, and practical exercises to ensure a comprehensive learning experience. Mobile apps and software. Navpoc. Navpoc is a mobile app that provides a suite of tools for celestial navigation. It offers features such as sight reduction calculators, star charts, and celestial body information. The app also includes tutorials and guides to help you navigate by the stars using your mobile device. Stellarium. Stellarium is a popular planetarium software that can be used for celestial navigation. It allows you to simulate the night sky and view the positions of stars, planets, and other celestial bodies. Stellarium can be a valuable tool for learning celestial navigation and practicing star identification. Celestial Tools. Celestial Tools is a software package that provides a range of tools for celestial navigation. It includes sight reduction calculators, star charts, and celestial body information. The software also offers tutorials and guides to help you navigate by the stars effectively. These online resources offer a wealth of knowledge and practical tools to support your celestial navigation endeavors. Whether you prefer websites, online courses, or mobile apps, there is something available for everyone. By utilizing these resources, you can enhance your understanding, improve your skills, and confidently navigate by the stars. Happy navigating. 10.3 Celestial Navigation Courses and Training. Celestial navigation is a complex and intricate skill that requires a deep understanding of astronomical concepts and the ability to apply them practically. While it is possible to learn the basics of celestial navigation through self-study and practice, many individuals find it beneficial to enroll in celestial navigation courses and training programs. These courses provide structured learning experiences and hands-on training that can greatly enhance one's proficiency in celestial navigation. In this section, we will explore the various celestial navigation courses and training options available to aspiring navigators. Formal education programs. Several educational institutions offer formal programs in celestial navigation. These programs are typically part of maritime or nautical science curricula and provide comprehensive training in both theoretical and practical aspects of celestial navigation. Students enrolled in these programs learn about celestial bodies, coordinate systems, navigational instruments, and the techniques used to determine latitude and longitude. They also gain hands-on experience through practical exercises and simulated navigation scenarios. These formal education programs often lead to certifications or degrees in navigation, which can be valuable for those pursuing careers in maritime industries. Nautical schools and maritime academies. Nautical schools and maritime academies are another excellent option for individuals seeking celestial navigation training. These institutions specialize in providing practical training for aspiring mariners and offer courses specifically focused on celestial navigation. Nautical schools and maritime academies often have well-equipped facilities, including simulators and navigational instruments, which allow students to gain hands-on experience in a controlled environment. The instructors at these institutions are typically experienced navigators who can provide valuable insights and guidance throughout the training process. Online courses and webinars. For those who prefer a more flexible learning approach, online courses and webinars offer a convenient option to learn celestial navigation. These courses are designed to be accessible from anywhere with an internet connection and can be completed at one's own pace. Online celestial navigation courses cover a wide range of topics, from the basics of celestial navigation to advanced techniques and applications. They often include interactive modules, video lectures, and quizzes to facilitate learning. Additionally, some organizations and experts in celestial navigation conduct webinars, which provide live instruction and the opportunity to interact with instructors and fellow participants. Workshops and seminars. Workshops and seminars provide an immersive learning experience for individuals interested in celestial navigation. These events are typically conducted by experienced navigators or organizations specializing in celestial navigation. Workshops and seminars often include lectures, demonstrations, and practical exercises that allow participants to apply their knowledge in real-world scenarios. These events also provide an excellent opportunity to network with fellow navigators and learn from their experiences. Many workshops and seminars are held in coastal areas or aboard ships, allowing participants to practice celestial navigation in a maritime environment. Navigational associations and clubs. Navigational associations and clubs are valuable resources for individuals interested in celestial navigation. These organizations often offer training programs and courses specifically tailored to celestial navigation. They may organize regular meetings, workshops, and training sessions where members can learn from experienced navigators and share their knowledge and experiences. Navigational associations and clubs also provide a supportive community of like-minded individuals who can offer guidance and support throughout the learning process. Mentorship and apprenticeship. One of the most effective ways to learn celestial navigation is through mentorship and apprenticeship. Finding an experienced navigator who is willing to share their knowledge and guide you through the learning process can be invaluable. A mentor can provide personalized instruction, practical tips, and real-world insights that may not be covered in formal courses. Apprenticeship programs, often offered by maritime organizations or experienced navigators, provide hands-on training and allow individuals to learn celestial navigation while actively participating in navigational activities. Conclusion. Celestial navigation courses and training programs offer valuable opportunities for individuals to learn and enhance their skills in this ancient art. Whether through formal education programs, online courses, workshops, or mentorship, aspiring navigators can find a variety of options to suit their learning preferences. By investing time and effort into celestial navigation training, individuals can acquire the knowledge and proficiency needed to navigate confidently by the stars. 10.4 Celestial Navigation Organizations and Communities. Celestial navigation is a fascinating and intricate art that has been practiced for centuries. While it may seem like a niche skill in today's modern world, there are still organizations and communities dedicated to preserving and promoting the practice of celestial navigation. These groups provide resources, training, and a sense of camaraderie for those interested in mastering this ancient navigational technique. In this section, we will explore some of the prominent celestial navigation organizations and communities that exist today. The Nautical Institute. The Nautical Institute is a global professional body for maritime professionals, including navigators, shipmasters, and maritime educators. While not solely focused on celestial navigation, the Institute recognizes the importance of celestial navigation as a fundamental skill for mariners. They offer various resources, training courses, and publications that cover celestial navigation and other navigational techniques. The Nautical Institute also organizes conferences and seminars where celestial navigation experts share their knowledge and experiences. The Royal Institute of Navigation. The Royal Institute of Navigation (RIN) is a professional organization based in the United Kingdom that promotes the art and science of navigation. The RIN offers a range of resources and publications related to celestial navigation, including books, journals, and technical papers. They also organize conferences, workshops, and lectures on celestial navigation, providing a platform for experts to share their insights and advancements in the field. The RIN actively encourages research and innovation in celestial navigation and supports educational initiatives to ensure the preservation of this traditional skill. The International Celestial Reference Frame. The International Celestial Reference Frame (ICRF) is a collaborative effort between various astronomical organizations and institutions worldwide. Its primary purpose is to provide a stable and accurate reference frame for celestial navigation and astrometry. The ICRF maintains a catalog of celestial objects with precise coordinates, which serves as a crucial resource for celestial navigators. By aligning their instruments and calculations with the ICRF, navigators can ensure the accuracy of their celestial observations and calculations. The International Association of Marine Aids to Navigation and Lighthouse Authorities. The International Association of Marine Aids to Navigation and Lighthouse Authorities (IALA) is an international organization that focuses on the development and harmonization of marine aids to navigation, including lighthouses, buoys, and beacons. While not exclusively dedicated to celestial navigation, the IALA recognizes the historical significance and continued relevance of celestial navigation in maritime operations. They provide guidelines and recommendations for the use of celestial navigation as a backup or alternative method of navigation, particularly in situations where electronic navigation systems may fail. The Celestial Navigation Society. The Celestial Navigation Society, CNS, is a nonprofit organization based in the United States that is dedicated to promoting and preserving the art of celestial navigation. The Society offers a range of resources and publications on celestial navigation, including books, articles, and instructional materials. They also organize workshops, seminars, and celestial navigation competitions to foster learning and skill development. The CNS actively encourages the exchange of knowledge and experiences among celestial navigators through their online forums and community events. Online communities and forums. In addition to formal organizations, there are numerous online communities and forums where celestial navigation enthusiasts can connect, share knowledge, and seek guidance. These communities provide a platform for discussions, Q&A sessions, and the exchange of practical tips and techniques. Online forums also serve as a valuable resource for troubleshooting navigational challenges and learning from experienced celestial navigators. Some popular online communities include dedicated celestial navigation subreddits, specialized navigation forums, and social media groups focused on celestial navigation. Conclusion. Celestial navigation organizations and communities play a vital role in preserving and promoting the art of celestial navigation. They provide resources, training, and a sense of community for those interested in mastering this ancient navigational technique. Whether through professional organizations, collaborative efforts, or online communities, celestial navigators can connect with like-minded individuals, learn from experts, and contribute to the ongoing development of celestial navigation. By supporting these organizations and engaging with these communities, we can ensure that the tradition of celestial navigation continues to thrive in the modern world. 11. Famous navigators and their celestial journeys. 11.1 Captain James Cook and his Pacific voyages. Captain James Cook is widely regarded as one of the greatest navigators in history. His voyages across the Pacific Ocean in the 18th century revolutionized our understanding of the world and paved the way for modern navigation techniques. Cook's expeditions were not only remarkable for their scientific discoveries but also for his meticulous use of celestial navigation to chart uncharted territories. In this section, we will explore the life and achievements of Captain James Cook and his significant contributions to the field of celestial navigation. Early life and naval career. James Cook was born on October 27, 1728, in the village of Marton, Yorkshire, England. He grew up in a farming family but soon developed a passion for the sea. At the age of 18, Cook joined the Royal Navy and embarked on a career that would shape the course of his life. He quickly rose through the ranks and gained a reputation for his exceptional navigational skills and attention to detail. The First Pacific Voyage. In 1768, Cook was appointed as the commander of the HMS Endeavour and set sail on his first Pacific voyage. The primary objective of this expedition was to observe the transit of Venus across the Sun, which would help determine the distance between the Earth and the Sun. To accomplish this, Cook had to navigate to the remote island of Tahiti with utmost precision. During the voyage, Cook relied heavily on celestial navigation techniques to determine the ship's position. He used a sextant, an essential navigational instrument, to measure the angle between celestial bodies and the horizon. By comparing these measurements with the known positions of stars and planets, Cook could calculate the ship's latitude and longitude accurately. Cook's meticulous approach to celestial navigation paid off, and he successfully reached Tahiti in time for the transit of Venus. This achievement not only contributed to scientific knowledge but also demonstrated the practicality and reliability of celestial navigation. The Second and Third Pacific Voyages. Buoyed by the success of his first voyage, Cook embarked on 2 more expeditions to the Pacific. His second voyage, from 1772 to 1775, aimed to explore the Southern Ocean and search for the fabled southern continent. Cook's navigational skills were put to the test as he sailed through treacherous waters and encountered harsh weather conditions. Despite the challenges, he managed to chart numerous islands and accurately determine their positions using celestial navigation. Cook's third and final voyage, from 1776 to 1779, focused on finding a northwest passage between the Atlantic and Pacific Oceans. Although he did not succeed in this endeavor, Cook made significant contributions to the field of celestial navigation during this voyage. He meticulously recorded his observations of the transit of Venus and made detailed maps of the Pacific Islands, which greatly improved navigational knowledge of the region. Legacy and impact. Captain James Cook's voyages had a profound impact on the world of navigation. His meticulous use of celestial navigation techniques not only enabled him to explore uncharted territories but also paved the way for future navigators. Cook's accurate charts and maps became invaluable resources for subsequent explorers and navigators, providing them with crucial information for their own journeys. Furthermore, Cook's voyages demonstrated the importance of accurate timekeeping in celestial navigation. He used chronometers, precise timekeeping devices, to determine longitude accurately. This innovation revolutionized navigation, as it allowed sailors to calculate their position with unprecedented accuracy. Cook's legacy extends beyond navigation. His voyages brought about significant scientific discoveries, including the identification of new species, mapping of coastlines, and observations of celestial phenomena. His meticulous documentation of these findings laid the foundation for future scientific exploration and contributed to our understanding of the natural world. In conclusion, Captain James Cook's Pacific voyages were a testament to his exceptional navigational skills and his pioneering use of celestial navigation. His meticulous approach to charting uncharted territories and his contributions to the field of celestial navigation have left an indelible mark on the history of exploration. Cook's legacy continues to inspire and guide navigators to this day, reminding us of the enduring significance of celestial navigation in our modern world. 11.2 Ferdinand Magellan and the First Circumnavigation. Ferdinand Magellan, a Portuguese explorer, is widely known for leading the first circumnavigation of the globe. His voyage, which began in 1519 and lasted for 3 years, was a monumental achievement in the history of navigation and exploration. Magellan's expedition not only proved that the Earth was round but also demonstrated the potential of celestial navigation in determining one's position at sea. Magellan's journey was not without challenges. He faced treacherous seas, hostile encounters with indigenous peoples, and mutiny among his crew. However, his determination and belief in the power of celestial navigation propelled him forward. During his voyage, Magellan relied heavily on celestial navigation techniques to determine his position and chart his course. The stars played a crucial role in guiding him across the vast oceans. By observing the positions of celestial bodies, particularly the sun and the stars, Magellan was able to calculate his latitude and approximate his longitude. To determine latitude, Magellan used a technique known as meridian altitude. This involved measuring the angle between the sun or a star and the observer's zenith, the point directly overhead. By comparing this angle with the known declination, the celestial equivalent of latitude, of the celestial body, Magellan could estimate his position north or south of the equator. Magellan also utilized the North Star, Polaris, as a reference point for determining latitude. As the North Star is located very close to the celestial North Pole, its altitude above the horizon corresponds to the observer's latitude in the northern hemisphere. By measuring the angle between the North Star and the horizon, Magellan could ascertain his approximate latitude. In terms of determining longitude, Magellan faced a greater challenge. Unlike latitude, which could be determined relatively easily using celestial navigation, accurately calculating longitude required precise timekeeping. Magellan did not possess the necessary instruments to measure time accurately, which made determining longitude a more complex task. However, Magellan and his crew made use of a rudimentary method known as dead reckoning to estimate their longitude. Dead reckoning involved estimating the distance traveled based on the ship's speed and direction. By combining this information with their latitude calculations, Magellan could make an educated guess about their approximate longitude. Despite the limitations of his time, Magellan's voyage marked a significant milestone in the development of celestial navigation. His determination to explore the unknown and his reliance on celestial observations paved the way for future navigators to refine and improve upon these techniques. Magellan's circumnavigation of the globe not only expanded our understanding of the Earth's geography but also opened up new trade routes and possibilities for exploration. His voyage inspired countless others to follow in his footsteps and explore the vast oceans using celestial navigation. Today, the legacy of Ferdinand Magellan and his use of celestial navigation lives on. While modern navigators have access to advanced technology and instruments, the principles of celestial navigation remain relevant and valuable. The ability to navigate by the stars continues to be an essential skill for sailors, aviators, and even space explorers. Magellan's journey serves as a testament to the power of human curiosity and the indomitable spirit of exploration. His determination to navigate the world using the stars as his guide has left an enduring legacy in the field of celestial navigation. As we continue to push the boundaries of exploration, we can look back at Magellan's achievements and draw inspiration from his remarkable journey. 11.3 Vasco da Gama and the exploration of the Indian Ocean. Vasco da Gama, a Portuguese explorer, is renowned for his significant contributions to the Age of Discovery and his pioneering voyage to India. In the late 15th century, the Portuguese were determined to find a direct sea route to the lucrative spice markets of the East, bypassing the perilous land routes controlled by the Ottoman Empire. Da Gama's successful expedition not only opened up a new trade route but also established Portugal as a dominant maritime power. His journey was made possible through the use of celestial navigation techniques, which played a crucial role in guiding his ships across the vast Indian Ocean. Da Gama's expedition began in 1497 when he set sail from Lisbon with a fleet of 4 ships. The São Paulo Gabriel, São Paulo Rafael, Berrio, and a supply ship. His mission was to find a route to India by sailing around the southern tip of Africa, known as the Cape of Good Hope. This was a daunting task, as no European had successfully completed this journey before. Da Gama's navigational skills and his understanding of celestial navigation were instrumental in ensuring the success of his voyage. Celestial navigation relies on the observation of celestial bodies, such as the sun, moon, stars, and planets, to determine a ship's position at sea. During his journey, Da Gama and his crew used several celestial navigation techniques to navigate the Indian Ocean. One of the primary methods they employed was determining latitude by observing the altitude of celestial bodies above the horizon. To determine latitude, Da Gama relied on the position of the North Star, Polaris. By measuring the angle between the North Star and the horizon, known as the star's altitude, Da Gama could calculate his ship's latitude. The North Star remains almost stationary in the night sky, making it a reliable reference point for navigators in the Northern Hemisphere. By observing the altitude of the North Star, Da Gama could determine how far north or south he was from his desired destination. In addition to the North Star, Da Gama and his crew also observed the positions of other celestial bodies, such as the Sun and specific stars, to determine their latitude. By measuring the angle between the horizon and the celestial body, they could calculate their ship's position relative to the equator. These observations were crucial in ensuring that Da Gama's fleet stayed on course and avoided straying too far off their intended route. Longitude, on the other hand, presented a more significant challenge for Da Gama and other navigators of his time. Determining longitude accurately required precise timekeeping, which was a considerable challenge at sea. However, Da Gama and his crew made use of the astrolabe, a navigational instrument that allowed them to measure the angle between the sun or a star and the horizon. By comparing these measurements with the known positions of celestial bodies at specific times, they could estimate their longitude. While celestial navigation was the primary method used by Da Gama and other explorers of the time, it was not without its limitations and potential for error. Factors such as weather conditions, instrument inaccuracies, and human error could all affect the accuracy of the calculations. Nonetheless, Da Gama's meticulous planning, skilled crew, and his understanding of celestial navigation allowed him to navigate the treacherous waters of the Indian Ocean and reach his destination successfully. Da Gama's exploration of the Indian Ocean opened up a new era of trade and exploration, connecting Europe directly to the rich markets of the East. His successful voyage paved the way for future explorers and established Portugal as a dominant maritime power. The techniques of celestial navigation that Da Gama employed during his journey laid the foundation for future advancements in navigation and contributed to the development of modern navigation methods. Today, while modern technology has largely replaced celestial navigation in everyday maritime practices, the principles and techniques developed by explorers like Vasco da Gama continue to be studied and appreciated. Celestial navigation remains a valuable skill for sailors, navigators, and enthusiasts who seek to understand the historical significance and beauty of navigating by the stars. 11.4 Christopher Columbus and the discovery of the New World. Christopher Columbus, an Italian explorer, is widely known for his historic voyage across the Atlantic Ocean in 1492. His journey marked the beginning of European exploration and colonization of the Americas. While Columbus is often celebrated for his discovery, his navigational techniques and use of celestial navigation played a crucial role in his successful expedition. Early life and ambitions. Born in Genoa, Italy, in 1451, Columbus developed a passion for exploration and navigation from an early age. He believed that by sailing westward, he could reach Asia and establish a new trade route. However, at that time, most people believed that the Earth was flat and that sailing west would lead to falling off the edge of the world. Celestial navigation and the voyage. To navigate across the vast and unknown Atlantic Ocean, Columbus relied heavily on celestial navigation. This method involved using the positions of celestial bodies, such as the sun, moon, stars, and planets, to determine his ship's location. The North Star. One of the key celestial bodies Columbus used for navigation was the North Star, also known as Polaris. The North Star is located very close to the celestial North Pole and remains almost stationary in the night sky. By observing the angle between the North Star and the horizon, Columbus could determine his ship's latitude. The sun and the astrolabe. Columbus also used the sun as a navigational tool. By measuring the angle between the sun and the horizon at noon, he could determine his ship's latitude. Columbus used an instrument called an astrolabe to measure this angle accurately. The astrolabe consisted of a circular disc with a pivoting arm and a sighting mechanism. By aligning the arm with the sun and reading the angle on the disc, Columbus could calculate his latitude. The sextant. Although the sextant was not invented until the 18th century, Columbus used a similar instrument called a quadrant. The quadrant was a handheld device with a quarter circle arc and a plumb line. By aligning the plumb line with a celestial body, Columbus could measure its angle above the horizon. This information, combined with the time of observation, allowed him to calculate his latitude. Dead reckoning. In addition to celestial navigation, Columbus also employed dead reckoning, a technique that involved estimating a ship's position based on its previous known position, course, and speed. By combining dead reckoning with celestial observations, Columbus could refine his calculations and make more accurate navigational decisions. Challenges and innovations. Columbus faced numerous challenges during his voyage, including the fear of sailing into uncharted waters, the lack of accurate maps, and the uncertainty of the Earth's size. However, his determination and innovative approach to navigation allowed him to overcome these obstacles. The size of the Earth. One of the prevailing challenges Columbus encountered was the belief that the Earth was much smaller than it actually is. Most scholars of the time believed that Asia was much closer to Europe than it truly was. Columbus, however, had a different theory. He believed that the Earth was larger and that he could reach Asia by sailing westward. The trade winds. Another challenge Columbus faced was the trade winds, which are prevailing winds that blow in specific directions across the Earth's surface. Columbus studied the patterns of these winds and used them to his advantage. By understanding the trade winds, he could plan his routes more effectively and take advantage of the wind patterns to propel his ships. Navigation in unknown waters. Navigating in uncharted waters was a significant challenge for Columbus. However, he used his knowledge of celestial navigation to determine his position and course. By carefully observing the positions of the stars and other celestial bodies, Columbus could make educated decisions about the direction in which he should sail. Legacy and impact. Christopher Columbus's successful voyage to the Americas had a profound impact on world history. His use of celestial navigation techniques paved the way for future explorers and navigators. Columbus's discoveries opened up new trade routes, led to the colonization of the Americas, and initiated an era of European exploration and expansion. While Columbus's legacy is complex and controversial, his navigational achievements cannot be denied. By relying on celestial navigation and his innovative approach to exploration, Columbus forever changed the course of history and expanded our understanding of the world. Celestial navigation continues to be a valuable skill and is still taught and practiced today. It serves as a reminder of the ingenuity and determination of early explorers like Christopher Columbus, who relied on the stars to navigate the unknown and discover new lands. 12. Conclusion. 12.1 The significance of celestial navigation today. Celestial navigation, the art of navigating by the stars, holds great significance even in today's modern world. While advancements in technology have provided us with more accurate and efficient methods of navigation, the principles and techniques of celestial navigation continue to be relevant and valuable. In this section, we will explore the significance of celestial navigation in the present day. Importance in emergency situations. One of the most significant aspects of celestial navigation today is its importance in emergency situations. In the event of a failure of electronic navigation systems or a loss of GPS signal, celestial navigation can serve as a reliable backup method for determining position and course. This is particularly crucial for sailors, aviators, and explorers who venture into remote areas or across vast oceans where access to land-based navigation aids may be limited or non-existent. Enhancing navigational skills. Even though modern navigational technologies have made navigation easier and more accessible, understanding the principles of celestial navigation can greatly enhance a navigator's skills and knowledge. By learning to navigate using the stars, one gains a deeper understanding of the Earth's position in the universe and the relationship between celestial bodies and our planet. This knowledge can help navigators develop a more comprehensive understanding of their environment and improve their overall navigational abilities. Cultural and historical significance. Celestial navigation also holds significant cultural and historical value. Throughout history, many civilizations have relied on the stars to navigate and explore the world. The ancient Polynesians, for example, used celestial navigation techniques to navigate vast stretches of the Pacific Ocean, enabling them to settle new islands and establish trade routes. By studying celestial navigation, we can gain a deeper appreciation for the ingenuity and resourcefulness of these ancient cultures. Connection to nature and the universe. In today's fast-paced and technology-driven world, celestial navigation offers a unique opportunity to reconnect with nature and the universe. By observing the stars, moon, and planets, navigators can develop a sense of wonder and awe for the vastness of the cosmos. Celestial navigation allows us to step away from our reliance on screens and gadgets and instead engage with the natural world around us. It provides a sense of connection to something greater than ourselves and reminds us of our place in the universe. Navigating challenging environments. Celestial navigation also plays a significant role in navigating challenging environments. In regions near the Earth's poles, where magnetic compasses become unreliable, celestial navigation offers a reliable method for determining direction and maintaining course. Additionally, in areas with dense cloud cover or limited visibility, celestial navigation can provide a means of navigation when other methods may fail. This is particularly important for pilots flying in remote areas or during long-distance flights. Preservation of traditional navigation techniques. Another significant aspect of celestial navigation today is its role in preserving traditional navigation techniques and cultural heritage. Many indigenous cultures around the world have developed sophisticated celestial navigation methods over centuries, passing down their knowledge from generation to generation. By studying and practicing celestial navigation, we can help preserve these traditional techniques and ensure that they are not lost to future generations. This preservation of cultural heritage is essential for maintaining diversity and enriching our understanding of human history. Inspiring exploration and adventure. Celestial navigation continues to inspire exploration and adventure. The idea of navigating by the stars evokes a sense of romance and discovery, harkening back to a time when intrepid explorers set sail into the unknown. Even in the modern world, the allure of using the stars to guide our journeys remains strong. Celestial navigation encourages us to venture beyond our comfort zones, explore new horizons, and embrace the spirit of adventure. Conclusion. In conclusion, celestial navigation holds great significance in today's world. It serves as a reliable backup method in emergency situations, enhances navigational skills, and preserves traditional techniques and cultural heritage. Celestial navigation also provides a connection to nature and the universe, aids in navigating challenging environments, and inspires exploration and adventure. While modern technology has revolutionized navigation, the principles and beauty of celestial navigation continue to captivate and enrich our understanding of the world around us. 12.2 The beauty and romance of celestial navigation. Celestial navigation is not just a practical skill used for finding one's way across the vast oceans or through the depths of space. It is also a captivating and romantic art form that has captured the imagination of explorers, sailors, and dreamers throughout history. The beauty of celestial navigation lies not only in its ability to guide us to our destinations but also in the profound connection it fosters between humans and the celestial bodies that adorn our night sky. One of the most enchanting aspects of celestial navigation is the opportunity it provides to witness the celestial dance that unfolds above us. As we gaze up at the night sky, we are transported to a realm where time seems to stand still, and the vastness of the universe becomes palpable. The stars, planets, and constellations that have guided sailors and adventurers for centuries become our companions, offering a sense of wonder and awe that is difficult to replicate in any other endeavor. The act of navigating by the stars requires a deep understanding of the celestial sphere and its components. It involves identifying and tracking celestial bodies, measuring their angles and positions, and using this information to determine our location on Earth. This process demands patience, precision, and a keen eye for detail. It is a delicate dance between the observer and the heavens, where each observation and calculation brings us closer to our destination. There is a certain romance in the simplicity of celestial navigation. Unlike modern technologies that rely on complex algorithms and satellite signals, celestial navigation requires nothing more than a sextant, a nautical almanac, and a star chart. It is a reminder of the ingenuity and resourcefulness of our ancestors who navigated the world's oceans using only their knowledge of the stars and the tools at their disposal. In a world that is increasingly reliant on technology, celestial navigation offers a glimpse into a simpler time when human skill and intuition were paramount. The beauty of celestial navigation also lies in its ability to connect us to the past. When we practice celestial navigation, we are following in the footsteps of the great explorers who charted unknown territories and pushed the boundaries of human knowledge. We are tapping into a tradition that spans centuries, linking us to the sailors of ancient civilizations, the seafaring adventurers of the Age of Discovery, and the astronauts who ventured beyond our planet's atmosphere. Celestial navigation is a testament to the indomitable spirit of exploration and the human desire to understand and conquer the unknown. Beyond its practical applications, celestial navigation holds a special place in our hearts because it allows us to forge a personal connection with the stars themselves. As we study the night sky and learn to navigate by its celestial inhabitants, we develop a deep appreciation for the vastness and beauty of the universe. We become attuned to the rhythms of the cosmos, recognizing that we are but small specks in a grand cosmic tapestry. Celestial navigation reminds us of our place in the universe and the interconnectedness of all things. In a world that is increasingly dominated by technology and instant gratification, celestial navigation offers a respite from the noise and distractions of modern life. It invites us to slow down, to look up, and to marvel at the wonders of the night sky. It encourages us to cultivate a sense of curiosity and wonder, to embrace the unknown, and to embark on our own celestial journeys. So, as we conclude our exploration of celestial navigation, let us not forget the beauty and romance that lie at its core. Let us cherish the moments of solitude under a starry sky, the thrill of discovering a new constellation, and the satisfaction of successfully navigating by the stars. Let us carry the legacy of celestial navigation with us, honoring the traditions of the past while embracing the possibilities of the future. And above all, let us never lose sight of the profound connection between ourselves and the celestial bodies that guide us on our earthly and cosmic journeys. 12.3 The legacy of celestial navigation. Celestial navigation has a rich and storied legacy that spans centuries and has played a crucial role in the exploration and navigation of our planet. While modern technology has largely replaced the need for celestial navigation in everyday life, its legacy continues to inspire and captivate those who appreciate the art and science of navigating by the stars. Historical significance. The legacy of celestial navigation can be traced back to ancient civilizations such as the Greeks, Egyptians, and Polynesians, who used the stars to navigate across vast oceans and deserts. These early navigators observed the movements of celestial bodies and developed methods to determine their position on Earth. Their knowledge and techniques were passed down through generations, forming the foundation of celestial navigation. During the age of exploration in the 15th and 16th centuries, celestial navigation became even more crucial. Explorers like Christopher Columbus, Ferdinand Magellan, and Vasco da Gama relied on the stars to navigate uncharted waters and discover new lands. Without the ability to determine their position using celestial bodies, these voyages would have been significantly more challenging and dangerous. Cultural and scientific impact. Celestial navigation not only had a practical impact on exploration but also influenced various aspects of culture and science. The ability to navigate by the stars allowed civilizations to expand their knowledge of the world and establish trade routes, leading to cultural exchange and the spread of ideas. It also played a significant role in the development of astronomy and our understanding of the universe. The legacy of celestial navigation can be seen in the names of stars and constellations, which often have historical and navigational significance. For example, the North Star, also known as Polaris, has been a reliable reference point for navigators in the Northern Hemisphere for centuries. The constellations themselves have been used as a celestial roadmap, guiding sailors and explorers across the globe. Technological advancements. While celestial navigation was once the primary method of determining position at sea, advancements in technology, such as the invention of the chronometer and the development of accurate maps, gradually reduced its importance. The introduction of radio navigation systems and, later, satellite-based systems like GPS made it easier and more efficient to determine position with precision. However, despite these technological advancements, celestial navigation has not been completely forgotten. It continues to be taught and practiced by sailors, aviators, and outdoor enthusiasts who appreciate its historical significance and the sense of connection it provides with the natural world. Celestial navigation serves as a reminder of the ingenuity and resourcefulness of our ancestors and the importance of understanding the fundamental principles of navigation. Navigating the future. While celestial navigation may no longer be a necessity in everyday life, its legacy lives on in various ways. It continues to be studied and researched by astronomers and navigators, contributing to our understanding of the universe and the science of navigation. Additionally, celestial navigation serves as a reminder of the importance of traditional skills and knowledge in an increasingly technology-dependent world. The legacy of celestial navigation also extends to the realm of human exploration beyond Earth. As we venture into space and explore other planets, the principles of celestial navigation will play a crucial role in determining our position and trajectory. Just as early explorers used the stars to navigate the vast oceans, future astronauts will rely on celestial navigation to navigate the vastness of space. In conclusion, the legacy of celestial navigation is one of human ingenuity, exploration, and scientific discovery. It has shaped our understanding of the world and the universe, and its influence can still be felt today. While modern technology has largely replaced the need for celestial navigation, its legacy serves as a reminder of our connection to the stars and the importance of understanding the fundamental principles of navigation. By continuing to appreciate and study celestial navigation, we honor the achievements of our ancestors and ensure that this ancient art and science are not forgotten. 12.4 Continuing the tradition of celestial navigation. Celestial navigation, once a vital skill for sailors and explorers, has evolved over the centuries. While modern technology has made navigation easier and more accurate, there is still a place for celestial navigation in today's world. Whether you are a sailor, adventurer, or simply someone interested in the art of navigation, continuing the tradition of celestial navigation can be a rewarding and enriching experience. Embracing the art of celestial navigation. To continue the tradition of celestial navigation, it is important to first understand and appreciate the art itself. Celestial navigation is not just about finding your way using the stars, it is about connecting with the natural world and understanding your place within it. By learning to navigate by the stars, you are immersing yourself in a centuries-old practice that has shaped the course of human history. Learning the fundamentals. To navigate by the stars, you must first learn the fundamental concepts and techniques of celestial navigation. This includes understanding the celestial sphere, celestial coordinates, and the various celestial reference points. It also involves becoming familiar with the navigational instruments used in celestial navigation, such as sextants and navigational almanacs. There are many resources available to help you learn celestial navigation. Books, online courses, and even local navigation clubs can provide you with the knowledge and guidance you need to get started. It is important to approach your learning with patience and dedication, as celestial navigation requires practice and experience to master. Practicing observation and calculation. Once you have a solid understanding of the fundamentals, the next step is to practice observation and calculation. Celestial navigation relies on accurate observations of celestial bodies and precise calculations to determine your position. This involves measuring the altitude and azimuth of celestial bodies, such as the sun, moon, and stars, and using these measurements to calculate your latitude and longitude. Regular practice is essential to develop the necessary skills and confidence in celestial navigation. Find opportunities to observe the sky and practice taking measurements with your sextant. Keep a logbook to record your observations and calculations, noting any challenges or insights you encounter along the way. By consistently practicing and refining your skills, you will become more proficient in celestial navigation. Navigating real-world scenarios. To truly continue the tradition of celestial navigation, it is important to apply your skills in real-world scenarios. This could involve planning and executing a celestial navigation voyage, whether it be a short coastal trip or a longer offshore passage. By relying on celestial navigation techniques, you can navigate without the need for modern electronic devices, connecting with the ancient art of navigation. During your voyages, pay attention to the challenges and obstacles you encounter. This could include adverse weather conditions, equipment malfunctions, or unexpected navigational errors. Use these experiences as opportunities to troubleshoot and problem solve, honing your skills and deepening your understanding of celestial navigation. Sharing and preserving the knowledge. Continuing the tradition of celestial navigation also involves sharing and preserving the knowledge for future generations. As you develop your skills, consider becoming a mentor or teacher to others who are interested in learning celestial navigation. This could involve leading workshops, giving presentations, or simply sharing your experiences and insights with fellow navigators. Additionally, it is important to support and contribute to celestial navigation organizations and communities. These groups play a vital role in preserving the knowledge and promoting the practice of celestial navigation. By joining these organizations, attending events, and participating in discussions, you can connect with like-minded individuals and contribute to the ongoing legacy of celestial navigation. Embracing the journey. Continuing the tradition of celestial navigation is not just about reaching a destination, it is about embracing the journey itself. Celestial navigation allows you to connect with the natural world, gain a deeper understanding of the cosmos, and develop a profound sense of self-reliance and confidence. It is a journey that transcends time and technology, connecting you with the explorers and navigators who came before. So, if you are captivated by the beauty and romance of celestial navigation, embrace the tradition and embark on your own celestial journey. By learning, practicing, and sharing the art of celestial navigation, you can keep this ancient practice alive and inspire future generations to navigate by the stars.